In this one, we're going to build a pipeline to deploy our Next.js applications to the AWS ecosystem. We're going to do this using a tool called SST. Now, the way our application is going to work is, of course, we'll have a front end that is written in Next.js, which gives us the advantage of writing our front end in React.js. Because Next.js is a React framework, it also will handle the routing for us. Now, traditionally speaking, if you were going to want to deploy it to AWS yourself, there's a lot of manual steps in there that make it really, really challenging to make that happen. SST automates all of that and makes it really easy to then use AWS within a Next.js application. So one of the other challenges that comes up with deploying any application is what database are we going to use with it. And for that, we're going to be partnering up with Neon, the serverless Postgres database itself, because it has a lot of amazing features to be really well suited to be used in a Next.js application. Now, I've actually covered the integration between Next and Neon before, but the idea here is deploying it to AWS and having a pipeline that not only can we deploy it, but we can also deploy multiple stages of that application, which means that SST is really well suited to help us with that deployment process. And then Neon is really well suited to ensure that we can stage our application, and then we'll put it all together by using GitHub Actions to actually approve when those stages are ready to go into full production and to be the actual official, website that we want to send our visitors to. So all of this is super exciting to me. So thanks to Neon for sponsoring this series and helping bringing it to life. Let's go ahead and take a look at the demo of exactly what it is that we'll be building. Hey, in this tutorial, we're going to be deploying this landing page right here. Now, a landing page is an entry point to what your app could be. It helps you gauge interest from users to see if you should build out more and more features. So to do this, we want a production version, and we're going to do that in this entire series step by step. The tools we're going to be using is Next.js. This, of course, is going to be a React framework that does the front end and the back end of our application. It's really powerful, it's really fast, and it works super well with serverless. Speaking of serverless, we're also going to be having a serverless database called Neon. This database will power the engine that we need to store all of the data and all of the interest from our users. We're going to be deploying to AWS using a tool called SST. This tool makes it really easy to deploy Next.js as a serverless backend on AWS. So both our backend will be serverless and our database is going to be really powerful. We're going to be using GitHub Actions to help us orchestrate how all of that deployment happens and also how it's going to automate the process for us as well. Now, what we can see here is we have multiple stages of deployment. We're going to just deploy a production version, which will be the final version, and then we'll also have a staged version in there as well. So that's going to end up happening because of GitHub Actions. So GitHub Actions will run through an automated process to do all of the commands necessary on our code to then create a pull request that we can approve with those changes, right? So in here, I've got this pull request. I can approve it right away, or I can look at the changes that have actually happened, which are right in here. And then I'll be able to then come back, make a conversation if need be, or I can go ahead and merge and confirm that pull request. And this will trigger off that workflow to actually deploy the new production version. Now, with all of this comes branching technology within our database itself. So the production version has a branch, the staging version has a branch, which is like a snapshot point in time of our database, which makes it really, really nice when we need to have different versions in production so that I don't just always approve pull requests, but I can actually see them in action. I can see the real value there. And then once they are actually put into production, CloudFront will distribute them all around the world. So it's incredibly fast and useful for our end users. And then you'll have your sales landing page out there and you'll be able to start gathering interest from your end users to eventually build out all of the other features that you might want. Now, if this is exciting to you, please let me know. I'm super excited to get going, but I want to show you the code first so you have a reference to go from throughout this entire series. All of the code is available at my GitHub on cfe.sh/GitHub or the Coding for Entrepreneurs GitHub look for deploy Next.js neon SST AWS tutorial repo name, and you'll find all of the code there. Now, the important part for this is so you can have reference for little bits and pieces that you might miss. Now, one of the things that we'll get into is the GitHub Actions workflows. These are actually really useful for referencing how we're going to be doing things throughout, including going into production and all of that. So I kind of think of these as like mini tutorials themselves. So do keep that in mind when you go forward. But all of the code is on here. Granted, the vast majority of the code is fairly straightforward, and a big part of the reason why we have this series is to talk about everything that's going on in there. So that's the code. If you do have questions in there, or if you find any issues, please let us know. Let us go ahead and open up those issues that might come up with your code, with your version of it, so we can at least help everyone else benefit when we do. We need to install a few fundamental tools to make sure that we can actually build this project and deploy it. The first one, of course, is Node.js, and specifically the LTS. Now, if you go to nodejs.org and download the LTS, this will probably work for the vast majority of you. Now, in my case, I'm on a Mac, so I'm going to be using NVM. This is the Node Version Manager, which just makes it easy to install the latest LTS and then to use any other version that I might see out there. Once I install that, I'm going to go ahead and install Pnpm. This is the Performant Node Package Manager. This is the updated version of Npm, if you will. It's not built into Node, but it is a great tool and one we definitely are going to be using. Now, I also will be using VS Code or Visual Studio Code to write all of my code once we get there. So download this if you don't have a code editor that you like already. This one is free and it's great. Next, download Git. If you don't have Git installed in your system, you definitely are going to need this. This is for version control. This is so we can move our code around and also see all of our code history. If you haven't done Git stuff, I'm going to be doing very basic commands. They're not going to be really that challenging in this series. So hopefully you'll be able to use that with no problems. And luckily, VS Code has a lot of built-in support for Git as well. So even if you don't know these commands, VS Code will help you out. Now, finally, Pnpm and Npm have the ability to search third-party packages. This is really just code that other people have written that have released it so we can use it. We're going to be using a lot of other people's code to write our own, to modify it to work for our purposes. So that's why we have Pnpm, and that's why we use Npm, is to be able to use npmjs.com, and we can search all kinds of packages in here, as we'll see as we build things out a little bit more. So let's go ahead and install Node.js. In my case, I'm using NVM, and I'm going to go ahead and run install --LTS, and this just installs the latest LTS version for me. Now, I already have this installed. I already have NVM installed, of course. I didn't show you how to do that. The point here, though, is now you should be with Node on your command line, and it should be the latest LTS. Now, this version itself is the one I'll be using, but from my experience, the latest version of Node.js is just going to be the most stable. The actual code itself is not going to mean that much of a difference. We'll have a lot of the latest features, but Node.js like 19 or 20 or 21, all of those sorts of things will probably work for this series with no issues. Unless, of course, major things change, but in my case, I don't think they will. Once you install Node.js, you get something called npm already installed. You also get something called npx also installed. We will be using both of these commands. In a moment, we'll use npm. npm, again, is that Node Package Manager. It's how we can install those third-party packages. npx is how we can execute third-party packages, which might mean that we need to install them, but it also means that we can execute them. It's a really useful tool. So in other words, we don't really use Node itself, the actual command for Node, very often, unless you need to get into the Node shell, which again is not something we will do very often. So the last thing I need to install, in my case, is going to be Pnpm. So to do that, I'm going to use npm install -g pnpm. Using this -g gives this a global install so that every project can use it. This is probably the last time you'll see -g in this series because we want to do local installs once we get there. But the idea here is now I have Pnpm installed, and I can just do -- version on this as well. And we can see the current version of Pnpm that I'm using. Now, if that didn't work, if the Pnpm did not install, just go to pnpm.io into getting started, and you can see a bunch of different installation options. And Pnpm can be installed without Node.js too, which is pretty interesting. So you can actually download the executable and install it and just run it. I haven't had experience with that myself because I always have Node.js installed, but it is pretty fascinating that you can use Pnpm without Node.js installed. I don't know why you would do that, but I'm sure there's use cases that are very practical. Cool. So now that we have everything installed, we'll go ahead and just sign up for the required services we need to actually use these tools. There's a few key services we need to sign up for to deploy our Next.js application into production. Now, this also means that we're going to use some of these services in development because we want our development environment to match our production environment as much as we can. Now, we've already installed some of the tools to do that, but now we're going to go ahead and sign up for the services. The very first one is Neon. Neon is a serverless Postgres database service. That means that we're going to be using Postgres as our database for our Next.js application. So once you sign up for that at this link right here, then we'll go ahead and configure it once we need it. Next up, go ahead and sign up for GitHub. GitHub, of course, is where we're going to store our code, but GitHub will also help us deploy our code, as we'll see in a little bit. Now, an optional service that you could use is Vercel. Vercel maintains Next.js, so actually deploying to their services is fairly straightforward to do. But the thing is, there might be a bunch of other services you might want your app to use, and that's why we're going to be using AWS. So Amazon Web Services is what you'll also need to sign up for. So be sure to sign up for all of these services right now so that we can actually start the process of developing and putting these things into production so you can really see what your app will end up being like. I'm really excited for it, so let's go ahead and get that app started. Now we're going to go ahead and create our Next.js application. Now I want to store this in a specific folder on my machine. So go ahead and open up your command line, whether that's Windows PowerShell or on Mac or Linux, you're going to use terminal. The idea being that we want to store all of your code projects in basically the same place. You don't have to do that, but it's something I like to do. So I always make the new directory at dev with this command here, and then I navigate into that dev folder. Now, in some of my projects, I will create the project folder right now, but in this project, we use npx create next app right now at latest. So on one hand, we could actually write all of the different files we need to run our Next.js application, or we can use create next app to, well, generate all the files for us and really just lay that foundation that we need for our Next.js application. So that's why I use npx create next app. Once you hit enter, it might prompt you to install this package right here, which is fine. If it needs to install it, then let it do that. Once it finishes installing, then it's going to ask you what you want to name your project. In my case, I'm going to call it my leads landing because, of course, this is going to be a landing page to store email leads. That's the goal here. That's what we're going to be deploying. Now, if you want to use TypeScript, you totally can if you know TypeScript. If you don't know TypeScript, adding TypeScript to the already complicated things that we're going to be doing is not advisable. You could do it, but we're going to stick with JavaScript to make things as concise and as simple as possible without going into what TypeScript can do. TypeScript can be great, but it also can complicate things quite a bit for those of you who are a little newer to using Next.js, okay, or JavaScript in general. Next up, of course, is ESLint. We'll just go ahead and say yes. We will be using Tailwind CSS to make our project look a lot better, and Next.js does a great job of handling this and make it really easy to use. We will be using the src directory, and we will be using App Router. If you've used older versions of Next.js, you might be familiar with Page Router. I highly recommend App Router because the developers of Next.js recommend the same. I'm going to go ahead and not change the import alias. I'll just use @. We'll see what that looks like in a little bit. And of course, what this is doing is it's going to install all of the dependencies for my project. It's also going to give me a bunch of boilerplate code, which is available at this folder right here. So with this in mind, I'm going to open up VS Code. I'm going to create a new window here. So once you do create a new window, then you're going to want to add this project in here. So from here on out, we're pretty much only going to be using VS Code to work with this project. So let's go ahead and configure this now as well. I'm going to open up that folder I just created at Leads Landing right here. Great. looks good. Next, I'm going to go ahead and save this workspace as, and we just want to save it in here as well. The next thing I want to do is open up the terminal window inside of VS Code, which you can do by going into terminal on the menu bar and hitting new terminal, or you can learn the control tilde command, which will toggle this terminal from being opened, which is really nice. So with this in mind, I'm going to go ahead and run in the terminal Pnpm and update. So I like using Pnpm update. Sometimes I use Pnpm install, but update is really nice if you ever have any caching issues with Pnpm, which does happen for sure. So I'll do Pnpm and then run dev here. Now again, if you just did npm run dev, this will probably work for you just as well. You could also use yarn. There's a lot of different things that's going on. So with this in mind, we see our local host here. And if I open this up in my web browser, there we go. We've got Next.js running and it's good to go. So the thing is, of course, if we wanted to make any changes to our app, we would go into src app and page.js, for example, and we can scroll down and we can make a change here, right? So we've got a bunch of different links in here that you might want to change. We also should have the Next.js logo in here, which is this right here, which I'm just going to change to leads landing, save it. Notice that my actual server is still running. So when I save it, it actually recompiles. It does all the things I need. And there's my leads landing text right there. Fantastic. Of course, we need a bunch of other things that we want to change here, but I wanted to point out all of these yellow and green things that are going on. So if you're new to VS Code and if you're new to Git, this is what's going to save you in many ways. VS Code has version control through Git already there. So what I can do is I can just add all of the changes I just made, just like that. And then these are staged, which means we haven't committed them yet. We haven't said, okay, these are for sure what I want to change. We can add in a message now to make that change. And I'm just going to be calling this the name of this actual lecture, which is 5-create Next.js app. I'm going to use the leave out periods and stuff like that. But there I go. I committed it. And now I have done my first commit and I created my application itself, which is cool. So that gives us very powerful tools at our fingertips without really learning all the nuances that go into them, so we can actually still build something practical. So with this in mind, I actually want to take what I've changed and added and made, and I want to put this on GitHub already. I want to get in the process of constantly adding code to Git and then bringing it into GitHub as well. Let's take a look. Now we're going to take all the files we've stored locally and we're going to push them to a remote location called GitHub in a place called a repository. Now this is directly correlated to the tool, the open source tool of Git, G-I-T. It is definitely related to that. GitHub happens to be one of the places that actually hosts the code through Git. GitLab is another option. And there's a lot of things you can do with both of them that are basically the same. There's a lot of things that are overlaps because they all have the same underlying technology, which is Git. So I'll talk a little bit more about that in a moment, but this is mostly for those of you who have never done this before. So if you're new to using GitHub or deploying with Git, this is going to be really, really useful for you. So once you go to github.com/new, just go ahead and go into the repository name. In my case, it's going to be deploy-next.js-neon-sst-aws, and I'll do tutorial. And then in my description, I'll go ahead and write basically the same thing. I just copied and pasted that. Next up, I'm going to leave mine as private. Now, by the time you're watching this, it will be a public repository that you can review. But I want to show you that private is okay. You can absolutely hide your code from the public view, which is exactly what private does. And if you do private, I can show you in just a moment how to actually allow other people to help work on this code with you. Next up, we're not going to initialize this repository with anything because of our boilerplate code, which I'll show you in a moment. But the main things being readme and git ignore. Those two are critical. Mostly the git ignore is critical on your repository. Anyways, we're going to go ahead and create this, and I'll let this run, and it will take a moment. Now, once this is up, of course, it's empty, right? There's no actual files in here. We need to add our files. But before we do, I want to mention that the the GitHub repository itself will host our code, but it will also allow us to run various things, run one-off processes on this code with GitHub Actions, which is something we'll work towards as well. But with this in mind, with our code repo ready, it gives you a few different ways on how you can set this up, which is actually fairly straightforward. So we see this git init, git add, and so on. Well, when we did our boilerplate code, if we look back into our project, we already have this git ignore file here. I said that was important because it is. We also have this readme file, which is not nearly as important, but I did change it a little bit before I started recording this one. But the idea being that the create next app, the actual npx create next app, command and tool actually initialized a git repo for us, which is why I can do git status and I don't need to do git init already. I mean, you can, but you really just don't need to. So you could run through all of these things all over again, or you could just add the remote repo origin. Okay, so I'm going to go ahead and add this one. I'll explain this in a second as well. With that added, I'll just go ahead and do git push. Right? So notice that the README is still yellow. That's on purpose. And so I'm going to come back into my github.com now. I'll refresh in here. And what do you know? There is all of my code. Right? So that's the process of pushing code. Just git push. You don't have to add the remote every time. The remote is really just the URL here that we are using. But let's say, for instance, you wanted to add it again, like you were going to do GitLab or something. You would say maybe git add GitLab, and then you would grab the GitLab URL, and then you could do git push GitLab, and then the branch that you're on, which is most likely going to be main or master. But I'm assuming that it's probably going to be main for you. And there you go. So you can have multiple remotes in here, as we see here. In this case, my remotes are the same. So I'm going to go ahead and do git remote remove GitLab, because that's not actually GitLab, that's GitHub. But as you see here, I can actually push it to both locations, which I think is actually really nice to know, so that you can have duplicate copies of all of your code. And you can store it with duplicate services. And you can also self-host your own Git repository as well. There's a lot of different things that you can do with Git, which is fantastic. But what I want to show you is actually how to add files in with this minor change here. Before I do, I will mention this git ignore here. So what this will do is it will ignore files that should never be on your Git repo. So the node modules, this right here, these are third-party packages. This is third-party code. We do not need these on our Git repo, which is why by default, they are ignored. There's a lot of different files that you might want to ignore. Let's say, for instance, I created, not in the node modules, but in the root here, if I did .env and I did secret equals to ABC, well, that .env file, I never want that to be on Git. So what I would do then is jump into my git ignore here, and I would literally write out .env. And so now that .env file will turn a different color. It will turn gray. It will no longer be green, as in, hey, it's ready to be stored on GitHub. But now we see two things that are yellow. So I'm going to come in here and just say, I'm going to add my git ignore file here and say updated git ignore for .env. And then my README, I can see the changes here. Red is what's removed, green is what's added, and then what's on the right is what's coming up next. So I'm going to go ahead and add that and say updated README, and I'll go ahead and hit commit. And then notice that it has this up arrow here with this syncing. Sometimes you might see a down arrow if somebody else worked on the code itself. I'm going to go ahead and press that up arrow. Notice that it says this action will pull and push commits to and from origin. In this case, we're only pushing because nobody else is working on this code, just me. So having only me work on it makes it a lot more simple in terms of Git. Okay, so with that change, I did a push. I can refresh now inside of my Git repo. And what do you know? There's my README in there. And if I go into .git ignore, I will see this as well, right? So I'm not actually going to show you this many, many more times. I'm actually probably never going to show you this again unless it's really relevant to what we're about to do. So I just wanted to show you the fundamentals of using GitHub and Git. I'll recap them in just a second. But of course, if you did want somebody to use this with you, you can go into settings here, go into collaborators, and you can invite other people to look at this code. They don't have to do anything to the code. They don't have to edit it. They don't have to change it. They could just really just look at it. And that would be a way to do it inside of those settings. So just to recap, when you make a change to any given file, let me just close these out real quick. If you make a change to a file you want to track, like the README, you can just go ahead and say something like, hello world, ! Okay, so I made a change to README. So what do I need to do? I just need to let Git know about that change. So I'm gonna go ahead and add this in here. And I'll say updated README. I commit it. This is not yet on GitHub. So to have it on GitHub, I could press this button here, or I could do git push origin main, or oftentimes just git push, and that will do the same thing as this, almost the same thing, but it will at least push the code into GitHub. And then we refresh in here, and what we've got is that hello world there. Now, of course, I don't actually want that, so let's go ahead and repeat this. I'm going to go ahead and just delete that and do git status, and then git add, git commit, updated README, and then git push. So notice that I did the same thing with the git CLI as I was doing with the VS Code stuff. So like I said, I don't want to go into too much related to Git itself. If you have questions on this process, please let me know. But the idea being, this is the fundamental part of what we'll be doing to move our code around, to be able to push it through GitHub or any other Git repository we might need. Once we actually get this down, once our code is ready, then we'll use CI/CD, which stands for continuous integration and continuous delivery, with GitHub Actions. This means that we'll be able to actually run one-off processes based off of our code. In other words, I'll be able to use SST directly in GitHub Actions to do our full deployment. But until we get to that point, we're going to be doing all the deployment locally. In other words, we'll circumvent GitHub for a little while in terms of actually doing deployment until we got it down. So now that our code is actually stored somewhere, it's stored in a repository somewhere, I'm actually going to do a hello world deployment using Vercel. One of the fastest ways to deploy your Next.js application is to Vercel. Vercel maintains Next.js, so it only makes sense that deploying there might be one of the fastest ways to do it. Now, one of the most powerful ways to do it would be on Amazon Web Services, or AWS, because once you deploy to AWS, you unlock access, real simple access, to so many services. But all of this access comes at the cost of complexity. That's why we use the tool called SST. Now, we'll get to those in a little bit, but for now, I also want to highlight the fact that our GitHub repo will be able to go to either location. So we're going to start with a hello world to Vercel, and then we'll work our way up to using the AWS deployment, which I think is actually very powerful and definitely very achievable. It's just a little bit more complex than Vercel by AWS's very nature. So let's go ahead and start deploying on Vercel. Let's start off by going to sign up, click hobby, the plan type, mostly because we're just learning right now. Your name, I'm going to just say coding for entrepreneurs. Hit continue, continue with GitHub. And this is, of course, going to authenticate with GitHub. So it's going to allow you or ask you to approve it and all that. So if it doesn't redirect automatically, which this should happen pretty quickly, but I've been playing around with it, I'm going to go ahead and authorize Vercel here. This gives me access to my account, or Vercel access to it. Next, we need to import a Git repository here, right? So I'm going to install the GitHub application. We'll go ahead and hit install, and we'll click on the user account that I want to use, and then the repositories I want in here. So in this case, we're going to type out deploy dash and look for our deploy Next.js repository. Okay, I'm going to add one more because I actually have another project in here. So I've got two projects that I'm going to allow Vercel access to. And then I'll go ahead and say install, and there we go. So now I've got these two. And I'm going to select my deploy here. I'll hit import. And again, I'll just leave all of the defaults here and just hit deploy. And this should actually start building and deploying our application. Now, I'm actually going to go back into the dashboard here. In my case, I have this project already here. This is a pre-existing project that I already did. But if I refresh in here, I should see my deploy Next.js Neon and whatnot tutorial. And so this is going to be building my project here, and we can look at our build logs. This might take a couple minutes at most to actually deploy, and it'll be deploying on these domains. I'm going to let it finish and we'll take a look. So in 35 seconds, we have a production ready application, which I can open and visit. And what do you know? Leads landing. It's all there. Great. So now anytime I make a change to the repo, the Vercel application will be updated. And we can test this by making a change to our code. So if we go into our code, let's into page.js, leads landing, we'll go ahead and say live, save it. We'll go into our Git on VS Code, add in our page, updated homepage, commit it, and sync those changes, say okay. What's going to happen on Vercel is it's going to build another deployment for us. So if we go back into just the main deployment project itself, there we go. We see deployments are coming through here. And I actually did one off video, but it's going to create another one and it's going to deploy that we'll be able to look at these various domains. So Vercel definitely has the benefit of going super fast for deployments. It takes only a few seconds, where once we go into the AWS of it all, it might end up being like 10 minutes. But what we've got with Vercel itself, look how fast that was, right? I made the change, I committed it, I sent it to GitHub, and then Vercel built it and deployed it really, really fast. Of course, the 35 seconds to deployment on Vercel is fantastic. It's definitely one of the reasons why you might consider this as a deployment option. And the 10-minute deployment to AWS doesn't seem that fantastic. But the reason it is because we are actually going to be deploying it to something called Amazon CloudFront. Amazon CloudFront is a global content delivery network, which means that when we do our deployments, it's going to update this around the world. So our users around the world will experience faster speeds while using our application. Yes, it might take a little bit longer to actually deploy it, but it's deployed everywhere in the world. Now, this is not to say that Vercel is not fast, and it's also not to say that Vercel doesn't use a CDN. AWS just makes sure that once we are done, CloudFront is updated everywhere. That's why it takes a little bit longer, because it does take some time to update a CDN. So that's one of many reasons why you might end up using AWS. The point of this one was really to just show you how simple it is to get your application in production. So now what we want to do is start actually using AWS for our application as well as the tool SST. And we can test this by making a change to our code. So if we go into our code, let's into page.js, leads landing, we'll go ahead and say live, save it. We'll go into our Git on VS Code, add in our page, updated homepage, commit it, and sync those changes, say okay. What's going to happen on Vercel is it's going to build another deployment for us. So if we go back into just the main deployment project itself, there we go. We see deployments are coming through here. And I actually did one off video, but it's going to create another one and it's going to deploy that we'll be able to look at these various domains. So Vercel definitely has the benefit of going super fast for deployments. It takes only a few seconds, where once we go into the AWS of it all, it might end up being like 10 minutes. And I'll explain why when we get there. But what we've got with Vercel itself, look how fast that was, right? I made the change, I committed it, I sent it to GitHub, and then Vercel built it and deployed it really, really fast. So the speed is what we're sacrificing a little bit to deploy on AWS, the speed to deployment. But if you want to use something like the product of AWS, the SES, so if we needed to do emails, right? If we wanted to send out emails, the Amazon AWS Now we're going to go ahead and implement SST into our local Next.js project. It's actually really easy to do. So if we jump over into terminal, into our project, we can run npm create SST. Now, before I actually execute that, I have package.json open to really just show you the dependencies that are currently a part of this package. And then when I run npm create SST, well, what's really cool is it identifies that I'm already in a Next.js project. Now, a lot of modern tools do this, and it does it really well, which is super nice. So I'm going to go ahead and say why I want to continue and then hit enter. And this adds in a few template files to my project and then updates various things related to SST, as in my dev dependencies here are now having SST, and the AWS CDK, the Cloud Development Kit, that actual library is going to be really useful for us in the future. But the idea here is we also have an updated dev command here that I can run once I actually get SST fully configured, because right now it's not fully configured. So the next thing I want to do is, with this in mind, it gives me my next steps here, which will be Pnpm install. That's what I want to run because we are using the Performant Node Package Manager. If you want to run npm install, you can. So Pnpm or npm install, either one works. And then you can also do, every once in a while, you might want to run Pnpm up or Pnpm upgrade to upgrade various packages. And that's another thing that you might want to do from time to time, which is also fairly important when it comes to using these various packages. And since we're using a lot of boilerplate code, the way these dependencies will work is going to be in respect to actually upgrading various packages as we need to. So that's pretty cool. With this in mind, we now need to actually go into AWS, the console, so we can actually start using SST to deploy our Hello World example. Now we need to create an AWS user for our Next.js project. This user is going to have access to our AWS account so that it can provision and configure all of the various services that we want to use, like AWS Lambda, like CloudFront, and so on. So to do this, it's actually fairly straightforward if you've done it before. If you've never done it before, then this is going to be brand new to you. Now, there is references on sst.dev that you can actually use under docs. So if you actually click on docs here and then scroll down into advanced and then scroll down to IAM credentials, then you'll actually run through this. Now you could also do a search on their docs for IAM credentials as well, and you'll get this exact same file. Now what's going to happen here is we are going to create a brand new user in the AWS console under IAM. Then we're going to apply a policy for that user so they only have access to do what SST needs it to. In other words, we don't give them unlimited access to our AWS account. Sure, there's probably ways to make it secure to do that, but we want to get in the habit of limiting the amount of access we give to any given resource. In this case, the limit will be based off of all of the different services that SST will end up running, which we could talk about at a high level in just a moment. So at this point, you'll also need an AWS account. So go ahead and create an AWS account if you don't already have one. Now, I did mention before that you will probably need one. This is when we actually definitely need it. So once you log in, you'll see something like this. You might not have recently visited at all, but we want to do a search for IAM. In here, this will be where we will manage our access to the various AWS resources. Now, I want to make it clear that if you do this part incorrectly, either SST won't work correctly or you will accidentally give root access to your account to the wrong places. So it's actually really critical that you get this part right because AWS has a lot of services and that bill can add up really, really quickly if you don't do it correctly. So inside of here, we're going to go into users here and I'm going to create a brand new user. And this is going to be my leads landing AWS user, and it's like my Next.js tut or tutorial basically, right? It does not need user access to the console itself, so we don't need to check that one. All we really need is programmatic access. That's it. I'm going to create a user group in a moment, so I'm not going to add the user just yet. Instead, I'm going to go ahead and just skip this part and go to next. And then we will go ahead and review and create this user. Okay, so with this user created, we can come in here and go into security credentials and we can create access keys. At this point, this user should have access to do absolutely nothing, right? So our use case is going to be mostly our command line interface here, which gives us a few other options that you might end up using, or you could just say other. Now, again, there's a lot of like warnings and stuff around this because it's really easy to let these keys get out of hand. I'll just go ahead and say other, and we're going to go ahead and say Next.js plus SST as a description tag, and then there we go. So I've got my access keys now. So what I want to do is I want to bring these in locally. So I'm going to go ahead and copy them, and I'm going to put them in a file that I will not save just yet. And then I'll go ahead and grab both key values and paste this in here. Great. So the next thing I want to do is actually go back into SST's documentation, and we can see that there's this thing called loading from file, and then we can use the format just like this. Right? So I now have those keys, so I can bring in that format here and just replace the values where we need to, just like that. Okay, so this is the credential file that I'm going to use. Now I will say you could also put these in as environment variables. In other words, you can use AWS access key ID. You can actually export it as an environment variable, much like you would do with a .env file. You could do that as well. But unfortunately, doing that requires a number of steps that I'm just not going to cover right now. Instead, we'll just go ahead and use this file right here. And so what I want to do is I want to save it in a specific location. The location itself is pretty much the same regardless of what system you're on, as you can see here. So I'm going to go ahead and save this. I'm going to do Command S. Then I'm going to navigate into my user's root folder. I'm going to create a new folder called .aws, and we're going to use .aws. Right? Now, there's a possibility that you already have this file in here, and if you do, feel free to use the command line as you see fit. Next, of course, I'm just going to call it credentials, and there we go. So those are now my credentials that are stored into AWS. So what I want to do is I want to jump into package.json, and I'm going to go ahead and create a new script here, and we're going to call this deploy. This script is going to be SST Deploy, and then we'll do --stage, and I'm going to call it production. So the reason I'm doing that is so that I can do Pnpm, and then we'll go ahead and run deploy, and this will call that command for us. And so what it's going to attempt to do is actually deploy this script here, or all of my project. I can't do it yet because I do not have permission to do it yet, but it does show me my user. That's the important part we have here. I will do the policy in the next part, but the important part is that now SST is using the exact credentials that we have. So if you did need to have multiple credentials, like it says in here, you can absolutely add them, right? And then you would just add in something like this. So I will actually change the credentials to being our production, profile, if you will. And I'm just going to change my AWS profile in this command to being production. Just like that, so that I can run this again, and it should give me the exact same user and the exact same credentials, even though it doesn't have permission yet, right? And of course, if I added a policy that gives it admin permission, this would have worked, but we don't want admin permission. We want very specific permission so that SST can do what we want to do. Now it's time to actually implement that policy in this next part. Showing my credentials like this on a video is violating a cardinal rule of, well, securing your accounts. You shouldn't share passwords and information like that to anyone, even if it's on a video. Now, in my case, what I did here was to show you that rolling these keys is something you're going to want to do on a regular basis and make sure that it's done correctly. So to do this, go back into your user. Of course, if you have a lot of users in here, what you could do is you can actually grab the access key itself, do a search for it, and that will give you the correct user. Then you're going to go into security credentials, and then once again, you're going to go ahead and create a brand new one. So let's go ahead and create an access key here. I'll use other again. I'll hit next, and I'll paste in my description. I'll create a new one, and then I'll just go ahead and replace these values right here, just like that. I'm also going to bring my credentials back to being just simply default because, well, it makes it a little bit easier when I run my deploy command. So I'm going to go ahead and get rid of this. And of course, once again, I can run Pnpm run deploy, and it should actually still attempt to do what it did before with the exact same user. Of course, the permissions are not correct. Great. So with this in mind, I'm going to go ahead and hit done, and I'm going to delete my old credential, the one from a few minutes ago. So go ahead and delete it. And first off, you have to deactivate it, and then you're going to go ahead and delete it just like that. Okay, great. So now what we need to do is we need to create a policy that allows this user to actually deploy things. So this policy is coming directly from SST. And of course, if you go into the IAM credentials page, you can see there's the IAM permissions here. We're going to go ahead and grab this, and we're going to actually copy this IAM policy in just a moment. Now, before I do that, I want to mention that, yes, if you scroll up a little bit, you'll see grant admin access permission. I don't recommend doing this ever. I almost don't recommend doing it even if you have a Sandbox account. I think getting in the habit of using these policies is a really good idea. So that's the policy we'll end up using. But before I actually use this policy, let's go ahead and create a group that we will attach to this policy. So back into the IAM and the AWS console, we're going to go ahead and create a new group here. And I'm going to call this my Next.js SST and group. And then I'll scroll down here and hit create group. I didn't add anyone into it. I just created the group itself. So with this in mind, I'm going to go ahead and now I'm going to create a policy for this group. As we see here, this group has no permissions whatsoever. So I'm going to go ahead and create a policy as well as add my user here. The first thing I'll do is actually add in my user, which of course is my Next.js user. I could use both my Next.js user and my leads landing user. One is a example that I did through the research, and the other one is the one we're actually using. So I'll add both of these users. Now, the nice thing about this is I can now apply a policy to all of the users in this group. Now, in this case, the policy is going to be very specific to deploying with SST. If we needed additional policies, we could totally add them to this group, or we could just create a brand new group with those new policies and add the users that we need to add. Like in this case, maybe I don't need this Next.js user in here, so I could just remove that user, and then boom, the policies that are assigned to this group are no longer assigned to that user, even if there's multiple of them. So yeah, certainly can add in your own policies if you'd like. What I want to do here is I'm going to go ahead and create a new policy itself. So let's go into policies over here on the side, and we're going to go ahead and create a brand new policy. Now, one of the things you could do is you could go through and actually attach individual services on here. And if you go through the IAM credentials page, you will see all of the different policies that you might want, right? So by going into the copy IAM policy or going step by step on all of the permissions that need to happen, you can absolutely use that policy. So I'm going to go ahead and copy this policy here, just like this. And I'm going to bring it into my AWS account, into the JSON of it all, and we're going to paste it in here. And I'll just go ahead and hit next. And there's going to be my SST Deploy policy. Okay. So notice all of the permissions that are being defined in this. These are all the permissions that are happening. So these are all of the AWS services that this particular policy has access to, which is cool. And it gives us the ability to see exactly what's being provisioned here. You might remove some of these policies. Perhaps you don't want an RDS database at all. Well, we don't because we're going to be using Neon. But in this case, you could also have an S3 bucket. There's a lot of different permissions that this policy provides that you may or may not need. And in that case, you would just go through each one itself within the IAM credentials page on SST. So with this policy in mind, I'm going to go ahead and create it. Now that it's created, I'm going to go back into my user groups, go back into my Next.js SST user group, into permissions, and we're going to go ahead and attach a policy under add permissions. In this case, we want to get the customer managed policies, which is the ones right here. What we've got is this one right here. Granted, I have a few others in here as well, but the main one is the one I just created, which is the SST deploy policy. Notice that I have basically the same one from my research in here. Anyway, so I'm going to go ahead and attach this policy now to this group. Great. So this policy is now attached. So in theory, I should be able to come back into my project here and run the deploy once again. But it fails. So if I scroll up again, I see that it fails, right? It says no identity-based policy allows for this to work. So why did this fail? Well, it has to do with the policy itself. Going into the policies and back into customer managed, back into our specific policy, we can come in here, we can see the JSON, and what we've got is this right here. This is not our account. Our account is not 112233 and so on. Instead, our account is going to be listed in a lot of different places, but the easiest place to find it is on a user group or a user. And that's your account number right there. So this is actually what we want to use, not the other one. So what I'm going to do then is I'm going to recopy this IAM policy. I'm going to bring it into VS Code temporarily. You could keep it in there for good, but I'm going to bring it in here and paste it in. And what I want to do is I want to replace this with my actual account. So I'm going to go ahead and copy this, and more specifically, this part of it. So I'll go ahead and copy that, and we're going to search it. There's 9 instances of it. So maybe that's not the one that I want to do. Instead, what I'll do is just the colon with that account. And now I've got 19 instances of it. So it's really just the wrong account number. Going back into my group here, I'm going to grab my actual account and I'll replace it just like that. We want to make sure it's exact. We're going to replace all of them. Now we're going to go ahead and copy this new policy with our account in there, go into the old policy, into customer manage, grab it. We're going to go ahead and edit it. We're going to go ahead and grab the JSON again. We're going to paste ours in. We're going to hit next. We're going to go ahead and save those changes here. And we've got an error. So let's see why. I've got a space in here when I shouldn't have. So let's go ahead and refresh that, undo it, get rid of that space, and there we go. Let's try that again. I'm going to go ahead and go cancel, go back into edit, and we'll go ahead and back and paste it in, and then next. And there we go. So all of the same services are there. We're going to go ahead and save those changes. And now the policy is only for my account. Yours would be the same. So now I'm going to go ahead and try this again with that SST deploy. And what's going to happen is we're not going to get an error. It's actually now working correctly as it should. I'm going to go ahead and Control-C and cancel it out. It will actually need to do a number of things that we want to look at in the next one where we just do our hello world example. But now that we have our policy in place, we can actually start using this. I don't need this policy locally. You certainly can save it. I wouldn't recommend saving your account ID number in there necessarily. It's something that you don't necessarily need to expose. Not that it's going to really do anything if you do. It's not like a credential, but we now have our actual policy in place and we can start doing that deployment process. So let's go ahead and do that now. Now we're going to do our hello world deploy using AWS. Now we already started doing this, so let's go ahead and run it again with Pnpm run deploy. And of course, this is going to call our SST command deploy with a stage of production. The stage itself is important. We'll talk about this when we get there and when it's necessary. But with this being deployed to AWS, I'm actually going to get rid of it from Vercel at the same time. The reason I don't want it in Vercel is because I don't want Vercel to constantly be deploying this application as well, because it's not necessary, and especially all the things that I'm going to be changing, I'm not going to be doing in the Vercel version of it all. So you could, of course, keep the Vercel version if you want. That is not something I recommend because you definitely don't need it unless you want to do redundant work in both places. So I'm going to go ahead and delete that, and we just are going to run the project name and delete my project. The other thing about this is the stages. So the reason I said that the stage is important is the fact that you can have multiple deployment stages with SST. So in other words, you can come in here and do another stage. So we do deploy, let's call this our staging one. So then you would just change the stage to being staging. And so this might be the one you do before you promote it into production. So you don't actually need to stage it on another service at all. And keeping it all in one place makes a lot of sense, as we'll see going forward. Now, some of the things to notice, part of the reason why SST can take a little bit of time is the fact that it actually spins up a bunch of things that need to happen in order for this service to run. One of them, like the S3 uploader, there's actually a Lambda function that will use Python, of all things, to upload files into S3 for us. We don't have to think about it, but it actually does it for us, and it does it automatically. So there's all sorts of things that are built into SST that just works for us. And then the other thing that ends up taking a while is updating that CloudFront distribution, like I've mentioned. In my experience, this takes about 10 minutes or so to be fully updated, to be fully deployed. So I'm going to let that finish. But the other thing that I want to do is point out that open-next or .open-next is, well, trying to be committed to my project, which I definitely don't want to have happen. I also don't want SST to be committed either. So I'm going to go ahead and add into my git ignore. I already did the SST one, but I also want to add in .open-next, just to make sure that none of those files are being committed either. And it's really just the ones that I want to track, which are related to my code itself. So these are all cache files. All the whatever can be deleted, as well as the node modules can be deleted and should be able to be deleted, so you can start from fresh. The code itself, the stuff that will be on GitHub, is the stuff that we are going to want to keep. Okay, cool. So with this in mind, I'm going to go ahead and update my git commit. So I'll do git status. I'm going to actually go back into VS Code just to make it easy for everyone. I'm going to add in this section here, which is hello world with SST. We're going to go ahead and commit it. I'll say yes. I'm doing all of the changes, and I'm going to go ahead and sync them. So the reason I'm doing it this way is mostly to just show you that eventually we will use GitHub Actions to deploy it, very similar to like what we did with Vercel. So GitHub Actions will actually run what's going on here. We won't do it locally. Instead, we'll just make our changes and then push it into GitHub Actions, which will then create various versions of our application, whether it's a staged version or a production version. We will stick with just the production version for a little bit until we have everything working correctly, and then we'll start looking at how to do the staging stuff as well. So I'm going to let this finish, and then we'll come back and take a look at the actual distribution in just a moment. All right, so after that initial deploy, we see our CloudFront URL here. And if I go ahead and open it, there is my leads landing live page. So it is fully deployed, and we're in a really good spot. Now, before I go any further, what you can find is you can actually go into CloudFront itself, and you can watch the progress happening when you go to do an update, right? So in my case, I only have one distribution. If you're not familiar with which one it is, you can always just grab this right here, right in front of cloudfront.net, and do a quick search for that. And of course, it will give you the actual distribution itself. Cool, so let's go ahead and do an update and try to do our distribution again. So in my case, I've seen this take 10 minutes. I've seen it take 12 minutes. I've seen it take 30 seconds. It's really kind of different depending on what is going on with the system at large. So let's go ahead and update this with, we'll call this CloudFront Leads Landing Live. And I'll go ahead and run Pnpm, run deploy. And of course, this will deploy our new stage here, and it will take as long as it takes. So while that's actually building, there is one more thing that I'm going to look at, and we'll run it after this actually finishes building. And that is actually just taking everything down. So to do that, we'll use npx SST. This is going to allow me to call just arbitrary SST commands. And it's going to be remove, and then the stage that we want to remove. So in our case, the stage is production, right? Okay, so we'll do that in just a moment. With this, where it's at, let's go ahead and take a look at our application itself. Now, right now, it's actually not doing anything. Nothing's changed. If I look in CloudFront itself and refresh in here, the status is still just enabled. So it's not quite at the point where everything's ready to be updated. So even within 30 seconds, a minute or so, we don't have anything real substantial changing just yet, but we will in just a moment, and I'll come back when it does. Okay, so a little bit over a minute, it actually made a change. And if I refresh my app itself, then I should see that change, and there we go. Great, so that is actually pretty fast. It's working really fast for me in this case. Might not be going as fast for you, but it is for me. So now what I'm going to do is I'm going to remove this stage and hit enter. And all this is doing, of course, is removing the deployed state of this stage from CloudFront, from Lambda, from S3, it's removing all of that stuff, and it even shows you exactly what's being removed. And you can always review those things in your Cloud Console itself. Now, it's important to note that this is about the stage itself. So you can do this over and over again, right? So we alluded to it here, but you could have 50 stages if you wanted to. I'm not sure why you'd have that many, but you totally could. And the way it's currently set up is you'd be able to do that. Now, there are, of course, exceptions with AWS. Your account might not allow for that many deployments or that many CloudFront distributions, but that's not really the point. The point here is that SST makes it really, really easy to take down and also deploy your various, Next.js applications. And of course, now if I refresh in CloudFront, it's trying to go there and we've got nothing. This one is now saying disabled. And if I go into Lambda, which we haven't even looked at, but if you go into Lambda, you'll probably see a lot of things removed in here as well. And in a moment, it'll be pretty much all of these things being removed. But overall, the goal here is to get in the process or the habit of being able to add new stages, deploy them where they're at, right? So the production stage is probably where you'd end up using a custom domain of some kind. But the fact that we can actually have multiple stages is really, really nice for us. So of course, now we're at a point where we need to start modifying the stage, the actual code itself, so it actually runs the way we want it to. That is, ingesting data into a database somewhere so that when I do deploy different stages, I have a database that actually correlates to that stage, or at least a database that we can use and potentially have it correlate to that stage, which is kind of the point of all this. So feel free to run deploy again. We will do this many more times. So even if you don't do it right now, we will deploy it again. So let's take a look at the next part right now. So I went ahead and deployed a new version of our application to AWS, and that gives me that link here, and we can see here it is in production. So one of the first things I usually want to know is how do I use secret values in production? That way I can actually integrate my application to third-party services. In our case, it's going to be Neon and using the database URL string. Now, on one hand, you might be familiar with .env files where you can actually inject environment variables at runtime. But the thing is, the runtime itself is a little tricky as to what's going on and where we would actually inject this. So instead of us trying to figure out which service we're going to inject our environment variables on, we can use a built-in function for SST. Now this, of course, will still leverage something from AWS, which we'll look at in a moment. But the idea being is using SST to actually configure each secret we want to store and use in our application. Now, you might be well aware that a Next.js application has front-end code and back-end code. So all of the API routes themselves is where we would actually use our environment variables and the related libraries that we might need to call. That means that basically we're not going to use environment variables on something like page.js, but rather route.js, as we'll see in just a little bit. So in here, yes, we could still reference running processes. We can still reference injected variables locally, but it doesn't really work the same when we go into production, as you can test out. But what we'll do is the correct way. We will actually use the SST configuration for secrets. So let's go ahead and get started now. First thing that I want to do is actually want this to run locally, which I'll do that with pnpm run dev. Now, just as a recap, package.json has that script there, and it's an SST bind. So if I hit enter here, it's going to ask me what stage I want to use for this particular version of SST. Now, I will use my username, my local computer's username, which is CFE. I'm just going to use that. Now, you can change this at any time. Inside of the .sst folder, there's a stage file here, and it has that stage that we just declared. And so you, by all means, use that one when you're going through this. Now, the actual stage we use is going to be important for using our secrets. That shouldn't be that surprising, but that's exactly what's going to end up happening. Now, since I am working with this locally, it can also use my .env file, as we see here, which might get you into trouble. You might think, oh, I could just use that and then try to go to production. It's not going to work. So I want to show you how to do it right out of the gates. So to do this, there is a pretty good how-to guide right on SSTs for the config itself. So we're going to be doing a number of things related to this. The very first one is going to be setting our first key. So I'm going to go ahead and open up a new terminal window, and we'll run npx SST secrets set. Now we want to use all caps and then use spaces with underscore instead of the space. So in other words, secret underscore val, whatever value we want here. So something hidden, and then the stage. Now we just set CFE, so I'm going to go ahead and use CFE as well as my secret value stage. So this will actually set this secret value, but the question, of course, right off the bat, where does this go? Let's go into our console here, and I'm going to search SST, literally SST. You'll find the systems manager here. This is what we're going to actually open up. Then we're going to go into Parameter Store. Inside of Parameter Store, you will see a bunch of different parameters. In my case, I've got this leads landing. What do you know? SST, leads landing, CFE, my stage, secret, and secret val. Yes, I have other ones in here from testing another project, but the idea is there it is right there. Hey, what do you know? I actually have another one for leads landing in production, and more specifically, the site URL. That's pretty interesting. But what we've got here is this is actually a secure string, as we see here. So if I go ahead and open this up, I can see the value in here, and there's my something hidden value. Now, can I edit this? Of course, I can edit it right in here, or I could actually just go back into the command line and change it again to something different. And of course, that will set it. If I refresh in here, I'll see that I have a new version of this value, and I can see what it is. So that's actually where the secret's going to live. So this is how you set it. So how do we actually use it? Now, before I can use it, I actually have to bind it to my project, and more specifically with SST. So this part is a little tricky in the sense of when do you actually do this? Well, what's important is whenever you want to use this value, that's when you're going to update your SST. So I'm going to go ahead and also add this same exact value into production. I'm going to change it to something hidden in prod. Hit enter. So I have the same exact key value, which in this case is always secret. And I can also verify that in the parameter store itself by the various ones. And of course, we could always just run based off of our SST/leads landing here and do a quick search. And there's the few that I'm using. So I've got my production one and my local one. Great. So with this in mind, I can now come in here, and in my SST constructs here, I can bring in something for config. So what this means then is I can say my secret value. So secret, we called it secret val, and that's equal to new config. And once again, we'll bring in that stack, and then I'll use the secret val here. I'm actually going to pop this up one level here, right above Next.js site, right? And so now I've got my secret val config, and this should actually be new config.secret, and then the stack itself with the secret val. Then we want to bind this to our site. So I'll go ahead and pass in a parameter into the Next.js site itself with bind, and put in an array here of all of the secrets we want to bind. So this is how I bind it to the application. I can't use it just yet. I haven't shown how to use it yet, but you're going to need to do this for every new secret you end up using. Now, on one hand, you could definitely use longer secrets. Like you could set it to be a little bit longer than this. You might even be able to set it to actual JSON strings. I'm going to just do it on one-off values. The vast majority of the time, you shouldn't have too many secrets that you're going to be injected in here. And if you do have a lot that you want to end up using, then perhaps this method is not going to be the best for you. There are other ways like HashiCorp Vault. You could potentially use that as a way to inject your environment variables. That specifically is outside the scope of this series. We're really just going to be focusing on a handful of these config secrets so we can really build a practical application. So now, of course, we need to actually implement this, but to do that, we need to create an API route. Now we're going to go ahead and create an API route to use our secrets that we created with SST and AWS. So the API route itself will be run on AWS Lambda, and we're going to have a policy that doesn't necessarily cache things so that the route is dynamic and that we would be able to do any other kinds of API calls. So that's what we'll do now. Now, if you're using page router, not app router, the general concept is the same. Your API routes are going to be how you use these secret values from SST. So let's take a look. Let's open up a new page inside of our project here. I'm going to go ahead and create a folder called API, and inside of API we'll do route.js, just like it says in the file conventions for this. Next, we're going to look at route segment configuration. Here's a bunch of different configuration options we can have in here. So the ones I'm going to be setting is dynamic at force dynamic, revalidate. I want this to be 0. Fetch cache, I'm going to go ahead and do force no store. And then the runtime is going to be Node.js. So I like thinking about these things first, but basically I want to limit the caching for this, and I want to use Node.js as my runtime because that's what we'll be doing with AWS Lambda. It's going to be using Node.js. So these are those values here. Of course, you can read more about them, but the idea being that we don't want this page to be cached because we're going to go ahead and import config, the class itself, from SST, node, and config. Now, what we have here is a little bit different, although it looks the same, it's a little bit different than what we used in SST config. SST config uses the config construct, which is, this is how we use it. Inside of the route, we use config slightly different. So to do this, we're going to go ahead and export an async function called get, and it passes in the request. It must be named get, G-E-T, capitalized just like that to match the convention. Like you can see in the file convention itself, here's all the different options for the different HTTP methods we can support. In our case, it's just going to be the request of get. Next, I'm going to go ahead and import the next response from next/server. This will allow me to return a response, and it's going to allow me to return a response with some values. So we'll do next response.json, and I'll just go ahead and say hello and world. And then I can also pass in the status itself, which in our case will be 201. That status will probably change once we start doing database calls and all that. So with this in mind, let's go ahead and jump over into our route itself on our local application. So with it open, I'm going to just jump over into simply just /API, and that should give us this hello world. So now let's go ahead and go back into our config here. I'm actually going to unpack this config into our Next.js response. So let's go ahead and look at it now. If I refresh in there, there's all of the secret values that my application has. It has the stage, it has the app itself, and the secret value that I set, which is great. Now, of course, just generally speaking, you don't want to unpack the entire configuration. You don't want those secrets to come out. So I'll just go ahead and do const, and we'll say, secret and val equals to config dot secret val, right? So we see that this is basically a dictionary then. And so I can then come in here and say secret value, and there we go. Dictionary object. Either way, I can now have that secret value coming in. Now, of course, in the long run, we don't want to expose our secret value this way. It's fine for now, but just generally speaking, we're going to change that in the future. So, of course, our actual stage, we'll go ahead and bring this in here as well. So config.stage. And we'll go ahead and bring that in so we can go into production. So we save that and we refresh. There's our API. So at this point, what I want to do is actually deploy this all over again. So we'll run Pnpm, run, and deploy. Now, the important part with this deploy is to understand that this part plays a critical role in building this. If you don't have this caching policy, you're probably going to run into errors trying to deploy with this config item here, and more specifically these config items, because as it tries to build it, it's not necessarily going to have the correct stage available to build it to where it's static. There's probably a way around it, but at this point, I just want to build this out with these secret values and see how well that ends up turning out. Now, the other thing, of course, is the actual secret value that I'm using, I need to set prior to trying to use it, and I need to set it on each stage. Now, that's why I mentioned something like HashiCorp Vault or AWS Secret Manager. You might start using something like that to handle all of your secrets, mostly because, well, you might forget what secrets you set on any given stage itself. So it's kind of important to recap what you have saved and where, So then you can then come back into your parameters here and actually see all of your secrets that you actually have saved. In my case, I have the two that are most important, my local development one and then also my production one, to make sure that those ones are there as well. So I'll let this finish off and then we'll take a look at our Create Next App under the API itself and see if that secret ended up working just well. In my case, I actually just did a refresh in here and it looks like it's working. So it did actually update it really, really quickly. And there's my secret value hidden in production, or should be hidden in production with that stage. So that's fantastic. That's how we're going to actually connect to our Neon database in production as well as in our development mode. We're not going to use that .env file much at all. Now we're going to go into neon.tech and create our Neon project as well as a database for our Next.js application. So on neon.tech, I'll go into sign in and just click GitHub, and this will allow me to jump into my console. You might have a couple extra steps there to get to the console of Neon, but the idea here is we need to create a new project. So go into new project here and you can select whatever Postgres version you want. I'm going to be using the latest one at 16, but even the older ones will probably be fine for this. I'm going to call it Leads Landing, of course, to kind of match the Next.js project that we have. Next up is going to be the region that you pick. Now, you might pick one of these regions that's near you and just be like, oh, that's probably fine. I'm actually going to pick the region that my project has been deployed on in AWS, which in my case is US East 1, which is North Virginia. And this is also evident when I look in my SST config, which is this right here. So whatever value you have there, you're going to want to find the closest one to that value inside of your Neon project. Now, overall, it would be a good idea to do this, but if you are in Europe and you're using the one in Oregon, the latency is going to be a little bit longer. So you might want to change your SST deployment when you end up going that direction. But for now, I'm going to go ahead and use North Virginia. We'll create a project here. And this URL is what I want to copy. So I'm going to go ahead and copy this URL here. And I'm going to go ahead and run my npx SST secrets set database URL. It's going to be that value. Then we're going to do the stage. In my case, I'll do production. I'm also going to go ahead and press up one time and set it to CFE, and then maybe even set it to another one. So CFE being my local project, my local stage, right? So you could always set it to more if you'd like, if you have more stages, but I'm just going to leave it like that. With that in mind, I'm also going to go ahead and grab the sst.config.ts. I'm going to copy that secret val and call this my database URL, and then put that in here. Bring in database URL as another item that we're binding to. There we go. Next up, what I want to do is go into AWS, my console here, and refresh for my parameters in the AWS Systems Manager. Again, if you type out SST as a search here, you got your Systems Manager, and then you just would navigate over in from your Systems Manager. You would navigate to your Parameter Store, and then you can just search based off of your project itself, which in my case is SST/landing. And there we go. So there's all of our tiers here, and there's my database URL for my CFE stage, and then also my database URL for my production stage. Great. So with this in mind, I'm going to go ahead and take it one more step further. Go into my API route and do const db string equals to config dot that URL. And then I'll go ahead and just give a little snippet of it. And so I'll say db string is equal to that db string as a string. Then we're going to go ahead and slice it up to maybe like, I don't know, 25 characters, something along those lines. We'll save it. Let's make sure that our local server is still running. Looks like it is. So I'm going to go ahead and take a look at that API on my local server. And maybe it's not. So let's go ahead and try and rerun that dev server again. Oh, this should be a capital C. That might be part of the reason why it didn't work. So I'll refresh on my API here. And there's my dev string. Cool. That's looking good. I don't want that whole thing exposed, of course. So with this in mind, I'm going to go ahead and deploy it now. And we'll go ahead and run deploy. And that should give us that process for the idea of getting a secret, a new value that we want to import and use, and then connect to a third-party resource of some kind. And then we set that as a secret value on all the different stages that we want to use it on. And then we actually push it into production when we use it, which is exactly what I did right there. And what will end up showing up on our production value of this, which might take, maybe another couple minutes. And sometimes it takes upwards of 10 minutes, like I've mentioned before. But anyways, so with this in mind, I'll let it finish off and hopefully we'll see our production database string going in there. Now, of course, this doesn't mean that I actually connected to it or I did any of that stuff correctly, which it should have been correct. It most likely was correct. But the idea being that I actually haven't tested that part out yet either. But really, for me, I just want to know that this actually works, that I can actually get this particular string in production. It definitely should work, but if it doesn't, I want to know about it now before I start doing all of those integrations itself as far as my production app is concerned. So I'll let this finish and then we'll take a look back at the final value. Looks like it finished. So back into CloudFront, refresh in here, and there's my secret value. Great. So we have the conditions set with our Neon database. So it's time to actually integrate it with the correct tools so we can do all the things we want to do on our production application. Let's take a look at the Neon client application first, or the Neon client tool called Serverless right now. Now we're going to implement the serverless client from Neon. It's fairly straightforward on how we're going to do it. Of course, if you go to the GitHub documentation for it, you'll see how to install it, and then you'll also see how to use it. Now notice that database URL is an environment variable. We aren't using the environment variable. We are using config, as we've already seen. So let's go ahead and implement this now. First off, in our terminal, we'll do Pnpm add @neon database /serverless. Hit enter. Of course, this will add this to our project. Next, I'm going to go ahead and create a file inside of the lib folder. This file will be db.js, just like that. We're going to go ahead and import Neon from @neon database /serverless. We're also going to go ahead and import the config from SST/node/config. And then we're going to export an asynchronous function called dbClient. And this is going to return Neon of the config.database URL. So really, if that doesn't exist, then an error will happen with this. Next up, we're going to use this client to get the current time on the database, that is. So we'll go ahead and do export async function, and we'll say db now. And this is going to be equal to, well, first off, we're going to go ahead and grab SQL being await, and we're going to get that db client. So what we have here is just a way to separate things out a little bit in the sense that it's basically the same as this. So SQL is just the variable that they like to call it. So that's what we'll stick with. And so with that, I can actually use SQL or SQL commands right inside of here. Using these backticks, I can say select and now. This will call select now on the database, and that's what we'll end up returning. So this is just very basic on how we can actually connect to our database and run a database call. We will implement an ORM to do a lot of the database calls for us. We're just not going to do that just yet. Instead, I'm going to implement this dbNow function on my API route. So back into my API route, we're going to go ahead and import it with the getNow, or rather dbNow function from, and we're going to use that alias, so @/app/lib/db. Now this alias is nice because then I can move this command anywhere, and it's not relative or anything like that. So you might be familiar with the relative imports of like doing .. /lib/db or something like that. You no longer need to do that. You can just use @ which brings us to the root, that source folder, and then app itself, and then any given route that's in there. Super nice if you weren't already aware of it. Okay, so to get this now value, I'm going to have my async get function in here, call it. So I'll do const, and we'll call this our db result equals to await db now, and then const now equals to that DB result. Basically, if it exists, we'll get the first one and then the key of now. Otherwise, we'll just say null. And then I'll go ahead and bring this in as a value for our response. And I'll separate these things out so it's a little bit easier to read what is going on in here. All right. There we go. So let's go ahead and check this out locally. If I have that server still running, I see that there's that now value. So if I didn't actually unpack it like that, so if I just did something like DB result, you can see what the actual result is. And I do encourage you to do that sometimes when I do something that is maybe new to you, especially with a client like this. But the result itself will come back as an array or a list of values in there, which is why I unpacked it in the way that I did. But with this in mind, we now have a way to get what the time is on the database itself. So yet again, I want to go ahead and deploy this with its current value. So I still have that local server running. I'm going to leave that in with Pnpm, and we'll go ahead and run deploy here. Mostly just so I can see that this is also working in production. So we're adding little by little to make sure that our database and our production environment are meshing well together before we start building more things out. I like to do this incrementally all the time whenever deploying projects in this way. Now, it's certainly possible that you do all of the development and then start to figure out how to do it in production. But if we do it early on, then we can get in the cadence of just continuously deploying our application, which is exactly what I think you would want to do as well. Just make it better and better, just little by little all the time. So I'm going to let this finish deploying, which should be done in a few seconds. And there we go. Less than a minute, it's back. So that is the actual time it takes to call our database from our production environment. It's fantastic. Cool. So now what we want to do is start the process of actually storing data in here by implementing an ORM system, or an object relation mapper, which allows us to just basically write JavaScript and get SQL as a result. So you don't have to write a bunch of SQL yourself. We already did write some, but it gets a lot more complicated than just this. And then also making changes to a database, to doing these migrations, these schema migrations, is not always straightforward when you try to do it just with your own SQL, unless of course you know SQL well. So let's go ahead and take a look at DrizzleORM now. Let's take a moment to think about the things we want to store in our database, the actual columns we're going to store. Now, first off, we need our email, right? So we're collecting leads. That's the point of a landing page, is to collect leads. Next, we're going to go ahead and maybe we want their first name. Perhaps we want their last name. We also probably want some sort of timestamp as to when this happens. And maybe in the future, we're going to go ahead and add in a description of this event itself. But at the bare minimum, I probably just want email and timestamp. So that's what we'll start out with. Now, also with this, I want to have an ID for each one of these. As in, every time I add in a new value into my database, the ID auto increments. So to do all of this, we are going to be using a ORM tool called Drizzle. Now, if you're not familiar with ORMs, it basically allows us to write in our native programming language and not have to write in SQL. It basically does the SQL for us. So in our case, it's actually writing JavaScript that then gets converted into SQL. That's both for defining the schema, the way the table is designed, and also doing queries, that is inserting data, deleting data, retrieving data, all that. So that's what we're going to be doing with Drizzle. So to do this, we want to get started, of course, on drizzle.team, go into the ORM itself, specifically into Postgres, and then Neon, because that's what we've been using. So we're going to start here by adding in Drizzle and DrizzleKit. DrizzleKit is going to help us with our migrations, which we'll see next. But first, we'll go ahead and just define our schema with the Drizzle ORM. So we'll do Pnpm add Drizzle ORM, and then we're going to go ahead and do Pnpm add -d DrizzleKit. So Pnpm add -d DrizzleKit. And of course, that will install both of those things that we need. And then in package.json, we've got our DrizzleKit here, and then Drizzle ORM. We definitely need the ORM in production, so that's something we'll definitely keep. Next up, what we're going to do is we're going to define the fields that we want in a schema format. What this means is that we are going to define everything that we want our database to store inside of a file called schema.js. So in the lib, we're going to put the schema right in here. And so to define this, we're going to go ahead and import a few things. The first thing is going to be serial and PG table. I'll show you where these things are in just a moment. And then we're going to go ahead and do from, and it's going to be DrizzleORM / PG core, as in Postgres core. Now, the definition between other databases like MySQL is not that much different here, but it is something you should be aware of, that it is different. If you wanted to use a different database, I'm not sure why you would, but if you did, you totally could with Drizzle. So where this thing comes from is directly in the documentation. If you go into the schema itself under column types and PostgreSQL, you'll see all of the different column types you can use. And the serial column is an auto-incrementing column. That means it will start at 1, then 2, then 3, and so on, all the way up until you don't use it anymore. So that is going to be our very first column. So I'm going to go ahead and do export const, and I'm going to call this a lead table. And to define our Postgres table, we'll use PG table. We're going to give it a name, as you can see in this suggestion box here. We'll say leads, and then we'll go ahead and pass in an object or dictionary that will have our schema definition. Now, we already started that in this column here, so I can actually paste that in and just have our very few things that we've got. So ID, email, and timestamp. I'm going to change this to created at instead of timestamp. Okay, so first off, ID is going to be a serial value. And I can pass in the database value that I'll store it in as ID as well. So the database value I can change, right? So I could call this IDX if I wanted to. I could call it index even, but I'll stick with just simply ID. I could also name this something different, and it'll be stored different in the database. I typically like these things to connect as much as they can, unless of course the casing is a little off, as we'll see in a moment. So serial right here, we're going to set this as our primary key as well. This is for doing relations and stuff like that, but we'll just leave it in as just primary key for now. And then we'll go ahead and say not null. Next, we're going to go ahead and bring in email. And then finally, we'll stop with created at. So email, what is email? What is that actual data type itself? Well, we could look back in DrizzleORM and we could look for one called email. Of course, there's not actually a data type called email. Instead, it's text, right? You could use varchar or text, or varchar, variant character, or just text, which is basically, no limit, roughly speaking. So we're going to go ahead and use text for this. Emails have varying lengths, so it's hard to know exactly how long it's going to be. So I'll just go ahead and do text, and I'll put it in as email. And I'll make sure that this is not null. I don't want it to be empty in the database, much like the ID, I don't want it to be empty in the database. So using not null with serial is probably redundant. You probably don't need to do that, but it is something that I'll put on there. Now, as we're seeing here, is this is all JavaScript, right? It's fairly straightforward JavaScript, and it will be translated into Postgres data, as we'll see once we run our migrations. But for now, I want to do this created at. There's another data type that we can use called timestamp, or really a column value type that we can use. And that one's called timestamp. Part of the reason I renamed it to created at is so we can see that typically speaking, when you use a database, you use underscore or snake case for the column names. You don't have to, but it is very commonly done. Next, we're going to go ahead and add a default to now, which is available on a field like timestamp. We'll use now, much like we did with this select now. It's going to be the same value, but it will be set when this is inserted into the database. When this is created in the database, it will automatically set two of the columns for us, the ID and when it's created, which is great. Now, there are other column types, of course, other data types that we can use in here. So if you want a true false value, you can have that. You can have a decimal value. You can have a lot of things. You can even put JSON data in here as well. So of course, I'm not going to be exploring all of the things that you can do with the database itself, but there are a lot of options. So with this schema installed, we now need to create our first migrations. That's something that I want to do in the next part. Now that we've designed our schema, we need the process of actually letting our database know about this schema or making those changes. This process is called migrating our database. So typically speaking, what happens is you design your schema or you make changes to it, then you generate what's going to happen, then you make the changes. So right now we're going to generate what's going to happen, and then in the next part we'll actually go ahead and make those changes, or at least start that process. So this is a very, very simple schema itself, but even if it starts to get more complex than this, it doesn't actually matter based off of what we're about to do, which is to generate the migrations. So the first thing that we want to do is inside of leads landing here, I'm going to go ahead and create drizzle.config.js. This is one of the default ways to configure the actual schema migrations that we want to use. So I'm going to go ahead and do const and drizzle config. This is going to be an object that has our schema definition and then where we want our migrations to go. So the schema definition, of course, is inside of src under app, and then inside of the lib here, I'm going to go ahead and copy the schema.js. So just like that. Now what you're not going to do is use the @ sign here. You don't need to do that here. You want to use the actual relative path from drizzle.config.js, which is of course in the root of our project, to the actual schema itself. Next, I want to add these migrations into this migrations folder right here that I created off video. So this migrations folder, we can just go ahead and add in with src and migrations. Now, you don't have to call it migrations. I just tend to call it migrations because it knows exactly what I want it to be. In the Drizzle documentation, you might see it in there as Drizzle. Personally, I find that a little confusing, so I'd rather just call it migrations because that's exactly what it is. So we're going to go ahead and leave it like that, and then we're going to go ahead and export this configuration as our default export. Great. Okay, so with this in mind, let's go ahead and run our first generation of migrations. It's actually fairly straightforward. It's npx, and then it's DrizzleKit generate :pg because it's Postgres, and then we can declare the configuration we're using. So drizzle.config.js, that actual file name itself, because I'm in the root running this command. I run it, and it creates a migration file for us. We will look at that in a moment, but in the meantime, I'm actually going to grab this and bring it into package.json because I want it in here as well, and I'll call it generate and just have it just like that. That way I can easily generate this and not necessarily have to remember it every single time. So what it created was a new migration file. So if we go in here, this is the SQL that corresponds directly to our schema. So this schema right here can be created in the database using this call right here. So quite literally, we can run this SQL file into our database and create the table. Another way to think about this is inside of this SQL command right here, I could quite literally copy and paste that schema or the actual migration file, the SQL file itself, and I could bring it in and just run it inside of that db.js. I could run it in here instead. Now, I don't recommend necessarily doing that all the time unless you are just rapidly prototyping and learning about it. But instead, what we want to do is we actually want to run DrizzleKit to actually do our migrations for us. We'll do that in just a moment. But before I get even there, I want to just make a quick change. So I'm going to go ahead and add a new field here. So instead of email, I'll go ahead and call it first name. And this time, instead of text, I'll do a varchar, or variant character, and then I'll use first_name. I don't care if it's null or not, and then I'll go ahead and say that the length is going to be up to maybe 150. That's a long first name, but that's 150 characters that we can have in here. So this length is kind of nice because now I can have a database related basically requirement that will not allow me to go over that length. And then I can also do last name. Very similar. Great. So I made some changes to my schema. So what do I need to do? Well, now I can run Pnpm, run generate, and this will create the next change that needs to happen, which in this case, it shows me these changes, right? So once again, I would be able to call the SQL command to make those changes, or we can actually call and run DrizzleKit to do it, which we will do here shortly. But just the general idea that we have is the ability to adjust what's in our database at any given time. We can also get rid of different fields too. So if, let's say, for instance, I wanted to get rid of them, I could comment them out and run this again. And then my next migration is going to say, hey, drop column if it exists. Great. And if I bring them back in, it's going to run it again, and it's going to create that next migration. So at some point, this migration history is going to get really big, and there is a way to kind of tighten it up a little bit, but I'm not going to worry about that right now. Instead, what we're going to worry about is actually making these changes in our database. So let's go ahead and see or start the process of doing that now. At this point, we need our database to match what's in our schema code. We need our database to have this table with these columns in it. And of course, we created those migration files, all of these .sql files in here, to actually allow for that to happen. So now we need to run them. Now, on one hand, you could potentially run them directly with SQL right here. We could call each one of these lines with this dbSQL command, right? Just like that, but going each one by one until they're done. Or what we could do is a little bit more efficient is use DrizzleKit to run our migrations. But we have a couple caveats we need to be aware of. The first one is the fact that we are deploying on serverless. Both our backend in Next.js is running serverless, thanks to SST and thanks to AWS Lambda because of SST. SST deploys it to AWS Lambda. Now, the reason this is a caveat is because that serverless application is not always running. So if we want to make changes, we want to do it in advance before the deployment actually happens. In other words, we need to actually run our migrations before we deploy the rest of our code. That's the point. That's really critical when it comes to applications that are serverless because there's no running process to just run those migrations. So we just want to make sure that they're done in advance. The next thing is our database is also serverless. So the actual driver we use, as it says right here, is a little bit different than what we've got here. So the actual configuration to make sure that those migrations run correctly anytime is slightly different than what's in this documentation. And there's one other big caveat, and that is how we actually connect to that database. Now, you're already aware that we have a connection string in the case of the database URL. We have this in our parameter store here, database URL, database URL. So we could, in theory, use that same database URL and put it in as an environment variable so that we can just update our DrizzleKit configuration to use that environment variable. But I don't want to do that. I want to make my entire project incredibly portable and leverage where I'm storing my secrets, which is in the AWS Secrets Manager, this parameter store. I basically always want to do this. I don't want to have to inject environment variables anywhere if I don't have to. I'm going to leave it in here. So how do we actually go about doing this? That means that we actually have to grab one of these values before I want to run my migrations, before I actually call this command. That's the first thing that we need to do before we even get the database driver working correctly. So one of the things you might think is possible is, oh, well, why don't we just grab the config like we did before, right here? Well, unfortunately, this is not possible because of how we're going to be running these migrations, and SST doesn't have support at this time to do what I'm about to do. In other words, I can't just grab this and come into my DrizzleKit config here, bring this import in, and then use basically the same configuration and do config.database URL. It just doesn't work that way, unfortunately. Fortunately and unfortunately. So what I want to do is I want to actually make my own command line tool to run something very similar to this. So that's what we're going to do. So what that means is we actually start with not using SST. We need to actually use the AWS CDK, or SDK in this case. We're going to use the SDK for JavaScript to actually run the proper command to call this stuff, to actually get these secret values out directly from that SDK. Now we're going to go ahead and start the process of creating our command line tool to run our migrations. What this means is we're going to use the AWS SDK to generate a way to extract our parameters from the parameter store. Then we'll use TSX to test that we can actually extract it correctly. And then in the next part, we'll actually turn it into our migrator. So to do this, we need to install TSX as well as AWS SDK as a dev dependency. So let's go ahead and jump back into our project here. We'll do Pnpm add -D TSX and the AWS SDK and hit enter. So the AWS SDK is going to go off of our default profile by default for our AWS configuration. That was another reason that I actually changed it back to being the default profile so that part would work as well. Which means that I don't have to inject any environment variables into what I'm about to do. Instead, it's going to use something that's already set up on our system. So the next thing is I'm going to use a command line tool to actually test that that's working correctly. So inside of lib here, we're going to go ahead and do our secrets.js. So what is it that we're trying to grab? And that is inside of our parameter store here, we're trying to grab any one of these things. So I'm going to go ahead and copy one of them. And I'll do const param name, and it's going to be equal to one of those, right? So this is our parameter name. So I, of course, want to break this out into various variables that I might want to change elsewhere. So the first one is going to be our project, for example, right? So that's leads landing in this case, and you could always change it, but basically it's this value right here. Next, we're going to go ahead and do our stage. And once again, I'll go ahead and use production, which is that value right there. So naturally, I might also want to have these as environment variables too. So I could change them if I wanted to, right? So process env stage and stage. Otherwise, we have our fallback at production. You could do this all throughout. So with this in mind, I can actually change this to being a string substitutable string. And that is, we're going to go ahead and bring in our, our project here. Capital project, and then our stage right here. And even if you weren't aware of these things being the correct names, you could just make the assumption here with we've got our project name is obvious, then CFE, that was the stage that we had locally, and then production is the stage there. And of course, we are going to test it as well. So then we're going to go ahead and grab our secret name value, or really just our secret name, and that of course is my database URL. Great. So we can go ahead and use that one as well. So now to put this into action, we're going to create our asynchronous function. And this is going to be just simply get secret. And it's going to be secret name. And then we're going to return some sort of value. Initially, I'll just say null. So of course, this right here should probably be down here, right? Because the secret name should be variable to the function itself. Okay, great. So now we need to actually call this parameter itself. Now I'm just going to give you this because it comes directly from the AWS SDK. I actually find it a little bit tricky to navigate that SDK because the documentation has so much to it. So we want to get the parameter command, and we do that by using the SSM client. So this also means that I should probably include my region. So we'll go ahead and do const and region. And in my case, it is going to be, well, let's go into AWS to just verify. And you should probably already know this, but it's US East 1, US East 1. Great. So now down here, we'll go and say const client equals to new. And this is SSM client. And we want to pass in our region here. And this is going to be based off of our argument. And once again, we can use those as environment variables too. Cool. So the next thing is we have our parameter name here. I'm going to go ahead and do my parameter, options basically. And that's going to be our name. And this should be capital name. And that's going to be our parameter name. The next one is going to be with decryption. And we'll go ahead and say true. Now the reason we say with decryption is because these are secure strings. Not all of them are, but the ones we're getting are secure strings. That's how SST sets them for us when we set those secrets with that command line tool. So those are the parameter options that we use. So then we are going to go ahead and say const command equals to new what do you know? Git parameter command with those options being passed to it. Okay. Next up, we'll go ahead and do our response is equal to await client.send of this command. And then to the actual response here is going to be response.parameter.value. And that should be parameter correctly. Okay, cool. So that's our get secret now. And at this point, I still have this secret name of database URL. I don't need that anymore. Realistically, if I don't have a secret name, then I'm just going to return null. Great. So now let's go ahead and use this in a command line application. So we'll go ahead in our SRC here. I'll do CLI, and we want to make sure that this is in the app actually. So we'll move it back into the app. And then inside of here, I'll go ahead and say migrator.js, because that's eventually what it will end up being. So now we're going to go ahead and import our get secret method in here. So we're going to do import and get secret. Now, what we have to do is this relative import. It actually automatically did it for me. You don't want to use the @ app import because that's based off of Next.js and it's not necessarily going to work here. So we want that relative import, or if that's not working for you, just go ahead and use all of this code right in the migrator itself. So it's a really standalone CLI itself. But at this point, I want this get secret in case I do actually want to use it somewhere else in my project for maybe a different stage or different kinds of environments. This is just a quick, easy way to do that. So I actually want it to be separate. And assuming that this works, then we'll be in a good shape. So what we're going to do here is we're going to do get secret, and I'm going to use database URL. And then we're going to go ahead and use our then catch call. So we'll do val equals to, and we'll console log out the value. In fact, I'll actually cut down the value just like we saw before, especially because it's our database URL. So I'll slice it down to like 10 or something like that. And then we'll do the same sort of idea, but instead of it being value, it'll be catch and error. And this will just be error. We don't need to slice it. And we probably just need to say something more like error and error. Great. And we don't need that final period. Okay, so now we've got our migrator. Of course, we have a lot of functions we'll need to add eventually to make sure that this is working, but I'm really just testing to make sure I can grab that database URL, right? So back into our package.json, I'm going to go ahead and create a new script in here called migrate, and it's going to be TSX, and then we want the relative path to the migrator. So I'll bring it in just like that, and we'll run this. Now again, it's important to note that this is not running through Next.js. So all of the things you might be familiar with Next.js aren't going to work here necessarily. Sometimes they might, but a lot of times they won't. And everything I have in secrets.js does not depend on Next.js at all, just the AWS SDK and a few other arguments that are fairly straightforward. So overall, I think this function is fairly straightforward, as well as the migrator in its current state. Okay, so what we want to do now is we actually want to run that migration. So we'll do pnpm run migrate, hit enter, and if it did it correctly, we should see our Postgres thing here. So if we change it to 25, we should also see that 25 value. Great. What if we actually try to get a value that just simply doesn't exist? If I run it now, then I get this, parameter not found type error. So to me, a quick way to solve this problem is just to return null. So basically bring in a try catch block inside of our get secret function and bring this response as the main command. Otherwise, we'll just go ahead and return null. So if there is an error, that's what we'll do. Now, there's probably a more elegant way to handle this, but since I'm mostly using it for the migrator, I just want to run it and see null. Great. So that actually ended up working, and it was pretty much successful based off of what I was trying to do. So now that we have the ability to grab any given secret, we need to actually build out our migrator to actually work, to actually run those migrations. So let's go ahead and take a look at how to do that now. Now we need to change our migrator.js into a perform migration function. We need it actually to work. So the first step for this, we'll just go ahead and say async function is perform migration. And this is now going to grab our secret, which we can just go ahead and cut this out and do const await, or rather const db URL equals to await that secret. And we'll go ahead and say if not db URL, then we will go ahead and return. Or you could say return null if you wanted to, but we'll just say return. So that's what our new call is going to be down here. Okay, so basically this will be migration performed or something along those lines. Great. So now that we can grab this database URL, what we need to do is we need to connect to Neon via WebSocket. So the migration itself, it might take multiple steps. So if you go back into DrizzleKit and go down to the running migrations, this command right here will most likely be multiple steps to actually run the migration. So we still will use this command. We're just going to connect to Drizzle a little bit differently and also our database a little bit differently. So we can go ahead and bring in this migrator here, and we can have this await migration basically down here somewhere. And the migration folder is going to be src/migrations, which is what we called it here and what we also called it in our Drizzle config. So it's the same as that, basically. Okay, so we need to connect to Neon via a WebSocket. So how do we actually go about doing that? Well, in the Neon serverless SDK, we should be able to find it in here. And even if it's not in here, there's a lot of places as to where we could find it. So let's go ahead and do WebSocket and just do a quick search for it. And here's our WebSocket support. So this is exactly what I'm going to be doing here. I'm going to copy this whole thing and we're going to bring it into our migrator right here. Now, a big part of the reason I want to copy the whole thing is if anything changes here, I can adjust now. Now would be the time I would be able to adjust. So basically what I want to do is I'm going to go ahead and then take out all of this code and bring it into our function. And we're going to go ahead and tab over a little bit. Okay. So what's happening here is we are going to be using WebSockets so we can actually run multiple queries at one time, which is actually what's happening right here. So we see begin, and then we've got multiple queries, we commit them, and then if there's an error, we can roll them back, right? So that's pretty cool. I don't have to do much myself. I just need to make sure that these are all working as they should. So now what we want to do is with this queries is this is actually where we're going to be performing our migration, or rather right here. So I can actually get rid of all that. And that's where we want to perform the migration itself, which is going to be right here. Of course, we don't actually have Drizzle connected yet, but that's essentially what's happening. That's what we want for this to work. Okay, great. So to do that, we need to grab the Drizzle DB. So going back into DrizzleKit, Drizzle ORM, PostgreSQL, into Neon, scroll down a bit. We've been using the HTTP version. Now we want to use the WebSockets version, which gives us this right here. So these things could change over time. They might be less complicated or just less configuration. I don't actually think it's that complicated, but if you do, at some point they'll probably be even more seamless than what we've got. And this command line tool might end up being a thing that, DrizzleKit has. So now we'll go ahead and bring in the Drizzle actual function here. And so here what I'll do is const db equals to await, and this is going to be Drizzle. This time, instead of it being just straight up Neon, it's the Neon connection. We're going to use the client there. And then we also need to have our schema come true. So we actually need our schema directly from the lib itself. So very similar to get secret, we're going to go ahead and do import all as schema from the schema itself, and then we'll come in here. Great. So once again, inside of schema, nothing about this is related to, our Next.js application. We do export this. We definitely need to export it so we can import it. But overall, we import everything so that when we go to connect to Drizzle, it has all of those schema items happening and then all of the migrations happening as well. So there we go. So that in theory should fully cover everything. So if we want to make this just a little bit better, we would also then say if require.main equals to the module itself, then we can run all of these right here. And I can do console log performing, or let's say running migrations. And then if it does end, we'll do process.exit of 0. And if there's an error, we'll do process exit of 1, signifying that. Cool. So now we've got a full-on command line tool that, in theory, will perform our migrations. So let's no longer have it in theory. Let's actually try it out. Now, before I actually run it, let's go into our Neon console, into our tables, and we should see none. So now we'll go into our terminal and run pnpm run migrate. And we get an error. It says perform migration then. So let's go back into our migrator. The error, of course, is I didn't actually call this function. So let's go ahead and scroll down and call it. Let's also make sure that we have no other errors. So I'll scroll up a bit. We've got DB URL here. It's not actually in use. So let's go ahead and make sure we get that as well. Great. So we'll save it. And now we'll give it a good run. Okay. And so it's attempting to run migrations, and then I get this error. So let's scroll up, and it says syntax error at or near C alter. Now I see that it's all capital alter, so I'm guessing this is SQL related. It actually only makes sense to be SQL related because that's everything we're doing. It doesn't say anything related to the connection, for example. So if I undo this and see the env database URL, this is related to not being able to connect to it, right? So what we want to do, of course, is I want to actually just change all of my migrations. So that means I'm actually going to delete this migration folder. Now, generally speaking, I wouldn't recommend doing this, but we haven't ever performed migrations before. Our database is empty. So all of these migrations were really just an example of what could be done, but we've got a lot of flip-flopping here. So we've got this, we created, looks like I saved something incorrectly. There's my problem, C alter. So I'm going to go ahead and save that. And perhaps you have that, perhaps not. Yours might have just worked just fine. So I was about to delete that migrations folder, but finding that C alter might have actually solved it for me. So let me go ahead and try and run it again. And now it looks like it's going to go ahead and actually run all of those migrations. So it had nothing to do with the migrations themselves. I must have just accidentally saved a C in here, and therefore C alter. Very strange that I did that, but nevertheless, there's my table now. So now that we can actually run these migrations, I can see them in real time now. So what we would end up doing is, let's say, for instance, we're going to go ahead and create another text field here. And I'll go ahead and bring in description. And now the process is this. We save that. We run our pnpm run migrations. So pnpm run generate. Okay, so that creates that migration file, then pnpm run migrate, and that will actually run those migrations for us. And sure enough, if we come in here into Neon and refresh in here, we should see our table, and there's description as one of the values. Of course, we didn't put it in yet, but we will very, very soon. So there is one other thing that we might need to consider at some point, that is the pooled connection. So the URL so far, all I've been using is the regular non-pooled connection, but you might actually want to have the pooled connection to make this a little bit more efficient. So I'll leave that to you, but basically the idea would be we create a new secret called pooled URL, and then we just use that throughout. You don't want to change the original one because we'll continue to use the non-pooled connection for all of our other requests, but if you need to change the pooled connection, you can. Now, these migrations shouldn't be massive. They should be pretty little. So every time we actually make a migration, then there's a good chance that you'll migrate it right away. In other words, the actual process of running those migrations should be minimal because of the snapshots that are going through here and the changes that actually happen. In other words, it's not going to change everything. It's not going to run everything every single time. Instead, it's just going to run it when it needs to, based off of the migrations folder that's in here, which is also pretty great. Cool, so now we have the ability to change our database schema and then insert it into our database at any time. So now we can actually start building out the rest of our application. Now we're going to go ahead and create a way to insert data into our database using Drizzle ORM. So to do this, we're going to jump into Postgres again, jump into Neon, and we're going to be using HTTP this time, not WebSockets anymore. So it's basically the same thing that we've got here. So I'll go ahead and copy this and we'll bring it into db.js and we'll paste it in near the top. So the first thing is our Neon stuff. We definitely want that. Same stuff, we just added in Neon config. And then we're also going to use Drizzle Neon-HTTP, not WebSockets like we saw before. Okay, great. So the first thing is we've got our SQL. I already have this Git database client thing here, which is actually not what I'm going to end up using in the same way. Instead, I'm going to have it like this. So I'll go ahead and say const SQL equals to that. Next, our database is going to be what we actually return. So I'll go ahead and return the Drizzle version of this. So what I can also say is something like use SQL only, and basically that's going to be false, but we'll say if it's true, then we'll go ahead and return just that SQL. So I can make this be true. Okay, there we go. So now that we've got that database client, I'll go ahead and get rid of this and this. Now I can use the neon config fetch cache true in the file itself, but I just want to make sure that it's actually when I initialize the client and it's done then. Okay, so next up, we want to actually use the Drizzle client. And to do this, we're going to export a async function, and we're going to call this add lead or insert lead or create lead. All of those are basically the same idea. Okay, and so for this, we'll go ahead and do const db equals to await, db client, and this is going to be false. Okay, by default it will be false, but we'll leave it in there just to make sure it's nice and explicit. And then we'll go ahead and use this to insert our data. So the data itself, we use await again, and db dot, and it's going to be insert. Then we need our schema. Then we'll go ahead and do our values, which is going to be the data object we'll send in. So let's say, for instance, email being something like ABC. And that's it. That's how we'll actually insert the data. But of course, this insert part needs the schema. So we'll also go ahead and do import all as schema from app/lib/schema. The reason I do that is so that I can just do schema dot and then grab any given schema that I have in there. Of course, you could always import the lead table directly as well, but I like just grabbing all of it. I think it makes it a little bit cleaner, and I can then modify it later if I need new schema values. And so there we go. That's how we actually can do this. And I can also return values here by using dot returning, right? And I can say that like something like my timestamp, I can use that as well. So if we go back into Drizzle ORM, scroll down a bit, we've got insert here, and we can do insert returning. That's this one. I can also return very specific values in there. So for example, I want to return just created, and that's going to be schema dot lead table dot, and it's going to be our created app. Cool. Or we could just say timestamp or something like that. That's basically modifying what's being returned. And so we can return this as that data just like that. Cool. So with this in mind, let's go ahead and actually use this. Granted, I don't have any arguments coming through really. So let's go ahead and add that in as well and basically pass this in here. So let's go ahead and use it in our API route. So probably won't end up wanting to use it on a get function in the future, but we will for now. So I've got my import from the database itself. I already had that. And so now what we'll do is say const, and we'll say lead result equals to await the add lead. And we'll add in an object here for email. And I'll say abc123 at abc123.com. We'll save that, and we'll put this in as a value on that get method itself. Okay, so let's go ahead and make sure this is all running. And it looks like my server is still, or my local server is still running. So I'll go ahead and open up localhost 3000. Let's see if this is running still. It might take a moment for this to fully come up. And I just really want to see that data come through. So go into our API again, and it should take a moment for it to actually send the request. But there is my lead result. What do you know? It's coming back, and it's just simply the timestamp itself. So once again, what we could do with this data here is we could actually modify it a little bit, right? So I can actually say that my const db result equals to that. And then if the length of it, so again, it's a list that's coming back here. So if the list value length is equal to 1, then I can grab that value. So we'll return just simply that and the 0th element dot timestamp because of the data that I have returning here. Otherwise, we can just return nothing. So we'll save that again. We'll refresh. This will actually insert another object into our data. Let's go ahead and see. Can't read undefined of. Oh yeah, so we've got our timestamp, db result timestamp. Let's go ahead and say not length here. We don't need that. We just need the 0th element. Okay, silly error, but let's go ahead and retry again. And there we go. So our lead result, if I refresh again, something new is coming through. Back into my console, I can actually go into my Neon console, look at the leads, and what do you know? There they are with all of those columns as well. And so that data should all be accurate or correct based off of what we currently have. So we might as well run Pnpm run deploy and, oops, not deploy, but deploy. And we'll actually see what this looks like in production as well. I'll let this finish deploying and then we'll take a look. And this production went in a little over a minute, but now I've got it actually there. So we'll go ahead and take a look. Granted, I'll just go to the home page first. Everything's looking good. Now go into that /API, run that again. And what do you know? There's my lead result. I refresh. I should get another one. Refresh, refresh, refresh. It's working so fast. It's incredible. Next up, we look into obviously the Neon tables, the actual leads themselves, and there's all of them coming through. Now, granted, we don't actually want this result, right? So this is merely to test that I can actually insert that data both locally and in production. And so from here, we just build out more and more of the data that we actually want. So we actually need to learn how to ingest some of that data using a form and then changing how our API endpoint ends up working. Now we're going to create our lead capture form, and that's going to replace our home page for the time being. So let's go ahead and jump into VS Code, into our app here. We're going to make a new folder called lead capture, and inside of there, we're going to go ahead and do forms.js. Okay, so this is going to be a client component, so we'll declare use client at the very beginning, and we're going to go ahead and export our default function, and this is going to be our lead capture form. And we will go ahead and return some JSX with the form value itself. And like many forms, we'll go ahead and do our input, and this type is going to be email. And we'll go ahead and say required equals to required, or rather just true. We could also leave it empty like that. I'll give it a name of email, and I'll give it a placeholder of your email. Close that off. Great. So with this in mind, I'm going to go ahead and import this into my page.js. Most of these things I'm actually going to get rid of, but for now, I'll just import it. So we'll import the lead capture form from our app and lead capture /forms. Great. So in main.js here, or the main block, I want to get rid of most of the things in here. The only thing I want to keep is this cloud landings form part. I want to keep that in there. And then I'll delete basically everything else up until that main component. Great. And then we'll go ahead and initialize our lead captures form. There we go. So we refresh in here, and there it is. Okay, so it's not much. We will style this a lot more later, but for now we'll leave it just as is. Next up, what I'm going to do here is I'm going to go ahead and also add in something like welcome. I just really want to bring the lead capture form right in the middle, and that's why I put that welcome tag there, or maybe let's just call it footer. back into our form, we need a way to actually submit this data. And to do that, we use button type equals to submit. And then we'll go ahead and say join list or something like that. And there we go. So the button itself doesn't have a great class right now. We will modify this quite a bit later. But for now, I'll go ahead and add in a class name of, let's just do BG and green, let's say 500. And then I'll hover BG green and 700. And then we'll just do our text white. Okay, and then I'll do px3 and rounded. There we go. And then we'll also add in a class in here. And it's going to be space x3. There, just a little bit of spacing between these two elements. Now, if you're not familiar with what I just did, it's all Tailwind CSS, and we will definitely come back to it later, and we'll use a few other resources to make that just even easier. Great. So with this in mind, I'm going to go ahead and actually handle this form data. So to do that, we're going to go ahead and handle this form by adding in the onSubmit handler. And to handle this, we'll create a fat arrow function. So this is going to be just simply handle form. It's going to take in an event, and then we will go ahead and console log the event, just like this. So the first thing I want to do with any form itself, we want to do event.prevent default. The default action for forms is to do what's called an HTTP GET, which will actually re-navigate our page. We don't want that. We just want to prevent it, which is why I use that prevent default. Next, what we want to do is we want to convert the data that's being submitted into form data. From form data, we're going to turn it into an object. From an object, we're going to turn it into JSON data. So to do this, we say form data equals to new, and then form data event.target. This, of course, is built into the browser, so we have to use that use client there. This form data doesn't really give us a whole lot, as you'll see once I log it. After I bring it into form data, I will turn it into just a basic JavaScript object. So we'll say data object equals to, and there's going to be object.fromEntries from that form data. And then the final piece of that would be to get it as JSON data, and that's going to be JSON. We've already seen this a lot, but JSON.stringify of that data object. And then I'll go ahead and be able to console log that JSON data out. And we can also console log the data object, so console log that also. And then the last piece would be to actually set up our fetch response, which will be our options first. And the method is going to be post. Whenever you submit data, it should always be post. Maybe put, but most of the time post. And then we're going to go ahead and do headers. And this is going to be our content type. And it's going to be application JSON. And then the body itself will be that JSON data. And then in a moment, we'll go ahead and use fetch in here. Now, I actually want to change this into an asynchronous function. So when I use fetch, I will be able to use the asynchronous version of fetch itself, which makes it a little bit easier to work with. But the idea now is grabbing our options. Our final thing will be those options. And then the fetch request will be something like this, where we do const and response equals to await. And it's going to be fetch. We need some sort of endpoint. In our case, it's going to be API leads. And that's probably what we'll use. We haven't set it up yet, of course. And then, of course, our options as well. And then we want to console log out that response. So the fetch portion, the actual submitting to the API, the backend portion, we will add that in the next section. But for now, I just want to make sure my form is working. So back into my browser, I'll go ahead and inspect the element here. We've got our console open, and we want to just do ABC at ABC, hit join list. And there's all of my different data. So as we see, form data doesn't really show me a whole lot. Once I turn it into a JavaScript object, then I can see that it's that dictionary or JavaScript object, so I can use key value pairs. Then we see a JSON stringified version of that, and then we can actually post that data, or at least this is what the fetch option will end up doing with that JSON string in there. And of course, having that content type of application JSON will be important when we submit it. So this right here is the foundation to doing pretty much any form within Next.js. We can always submit this back to our API, which has to handle it very similar to this GET route, but instead of being a GET route, it has to handle the very specific method that we're going to be using, which is the post method, also known as the HTTP post method, not the HTTP GET method. You typically do not want to submit data to be stored in your database using the GET method. You typically want to do it with the post method. So let's go ahead and implement the API endpoint to actually handle post data. In a moment, we're going to create our API endpoints to handle our form data. Now, the way I actually handled the form with the actual... In a moment, we're going to create an API endpoint to handle our form data. And I'm saying form data specifically because the way I designed the HTML form and the event handler was so that I can get any form data here. In other words, I would be able to reuse this regardless of what's actually in the form itself, which we'll see in just a moment. But you already see the makings of it with grabbing the form data and then turning it into JSON data. So now what we want to do is activate this response. I want to actually be able to send this data to the backend. So before I even run that, what I also want to do is indicate to my user that the form is actually loading. So what we'll do here is we'll import the use state from React. What use state will allow me to do is to declare a loading variable and set loading so that it reacts to that. So we'll go ahead and go back to use state, and the default value will be false. When I submit the form itself, I'll change that default value to true. When the form is done, then we will change it to being false again. So what that will allow me to do is basically change a few things related to the form itself. So we'll go ahead and say const btn label, and if it is loading, then we'll go ahead and say loading. If it's not loading, we'll go ahead and change it back to join list, which means that in this label, I can come in here and change it like that, right? So of course I could also disable this button if it's loading also. If it's not loading, the button won't be disabled, which means that I won't be submitting the button all over again, right? So we'll just leave it like that. There's a lot of different things we could do for the user interface. But now that we have the user interface a little bit more polished and also trying to submit data, we want to actually implement that. Now, before I do, let's go ahead and actually try to submit the data. So back into our front end, we'll go ahead and try and submit data. Of course, we get an error, 404, not found. So that is the API endpoint route that we want to configure. So API/leads, just like that. Now, VS Code has a really cool way to create new files inside of folders. So inside of my app here, I'll go ahead and go to create a new file, specifically file, not folder, and do API/leads/. Now, this, of course, will give me that API route. We have two options here. We can use page.js if we want it to render out an HTML page, or we can do route.js, which will allow me to have those API routes, which is what we've already done and we've already seen. But I just wanted to show you that how you can nest those routes. And this is a key feature of Next.js on how that routing ends up working. So of course, API/leads/route or API/leads is now a API route. And so I'll use route.js again and copy it and bring it into my new route.js. And I want to leave it like this or close to like this. And of course, we are now needing to handle not the HTTP GET, but rather HTTP POST. Mostly because when we submit data to our backend to be stored into our database, we want to use POST every single time. I mentioned that when we did the front end side. Now on the back end, we want to make it very, very explicitly POST. So the only way we can handle that data is by changing our API route to POST data. Cool. So with this in mind, what I want to do then is I'm going to get rid of a few things. I'm going to change the import database as DB, just like that. I no longer need the config variable because we won't use it anymore. When I go to add a lead, I will now use db.addLead, which we won't put in just yet. but I will get rid of a number of things in here as well. Cool. There we go. So eventually we'll have that add lead, and then we've got our JSON data. Now, typically when you store data in the database, when you post data and then add it to the database, you're going to do something called a 201 status. That means it was created. Otherwise, you would use 200, like if you were updating the data. But we're adding data into the database, so we're going to use it as 201. So the very first thing that you typically want to do is you want to verify that this is going to be the correct data type, the correct content type. Now, once again, we started with post. Now we're doing the headers. We want to see that the headers are correct in here in the case of application JSON. Then we'll handle the body data. Hey, what do you know? That's exactly the way I defined the options itself for the fetch also. That's on purpose, of course. Next, into our route, we want to now get that header. So we're going to go ahead and do const content type, and this equals to await request.headers.get of content-type. And what we can assume here is content type, the header itself will be lowercase on the request. We could probably even use it lowercase in the initial sending, but on the actual request into the backend, we can use it as lowercase. Now you could always console log the value of the headers themselves, and you can also check all different kinds of headers that come through here. Right now, we'll just go with the content type because we'll basically say if content type is not equal to, whatever we're going to do it, application JSON, then this is already not valid data, so I'll return a response with a status code of 415. It's not valid data, so we'll leave it as that. Now you can also add in a message of something like this and say invalid request if you wanted to have a message, so the front end could load up that message itself. But based off the status code itself, the front end could also load different data also, which is cool. It's something we won't touch just yet. But assuming it gets past this part, we could now unpack the body data, which is, in our case, JSON data. So now I can go ahead and say the const data equals to await request.json, and that is a function that will give us that data. Now, I already know what data I'm looking for in my backend. I want that email data, right? So I can also do const email, basically unpack the data itself, just like that. Now, if that data doesn't have email, this will be set as undefined, which would then, once again, I can say if not email, I can return a different kind of response. This time I can say status code of 400 and basically say email is required as the message. Now, we can always improve the message so the front end can improve its response to the user. But realistically, this not email should always be email because when we defined that input, we said it was required. This is just another check to make sure that it actually is required. So at this point, we have all of that required data, so we can finally get our lead result, which will be actually using that data just like that. And the only reason I'm using db dot instead of just simply the function itself is so that I can always use this. I can use other things in here like const now equals to await db dot get now, or what did I call it? Let's double check. It was db now, not get now, but db now. We can bring that in as well. And so that my timestamp is equal to this, right? So that's the lead result timestamp. So maybe we'll just call it lead result as well. And then db now is now, or rather db now. We could call those things the same as well. Cool. So the naming convention here, just using db allows me to call any given function in that module in a way that I think makes a lot of sense, right? So then I can also come in here and say result data equals to this dictionary or this object here. And then I can add on to that object as I see fit and then return that result data. Great. So now we fully handle this data. So back into our form itself, we can come back into our response. Once again, we could check all sorts of things with this response. I'm actually going to get rid of all of these other console logs here, so we don't need them any longer. So now what I can do is come back in and do console. I've got my response here. So the response data equals to await response.json. Hey, what do you know? It's almost exactly the same thing as the backend. This is on purpose. It's very well designed, but instead of it being a request, it's a response. It's a response from the backend. So now we can actually console log what that data is, and I'll go ahead and say response data is that response data, and we can take a look. Now, once again, we would probably want to check what the response headers are, whether or not it's JSON, but given that my content type is application JSON, it's probably safe to assume that the response will also be JSON. Now, I say safe to assume. That doesn't mean that you can't go ahead and actually build out more things to just ensure that you're getting the correct data types, but that's a little bit outside the scope of what we're trying to do here. So now, with this in mind, we're going to go back into our front end here. I just refresh everything to clear out the log, and I'll go ahead and submit a new email here. Hit joining. Notice it's loading. It's going to take a little bit of time, and there it is. Now, the next time I do it, it's probably going to be a lot faster. The reason it took a little time, of course, is because my database is serverless and thus will scale down when I'm not using it. And that's an example of that, right? So DB now is sending back an array, right? Like we've seen before. So once again, I could go back into db.js and I could change this very similar to what we did down here. So const db result of that is here. And we'll say if db result length equals to 1, then we'll go ahead and return that db result and the 0th element .now. Otherwise, we'll return null. And there's going to be hopefully no surprises here as to what ends up happening. We run that, and now we've got null. Hey, that's weird. So that's probably not what we actually wanted. So let's go ahead and just return back that db result. Let's try that again. Notice that it is not giving me that result, which is a bit strange here. Oh, that's why. So we've got await. We need to await this. And let's put now back. And we'll run that again. There we go. So we've got the lead result, and then we've got now. So we can see a delta slightly up between these two calls. Very, very slightly. But one is actually stored in the database. The other one is the time of now in the database. And it's going to be skewed based off of when I actually call it, as you might expect. So we refresh again. Well, actually, we didn't need to refresh because it would have updated already. Go to join that list, and what do you know? So almost identical. It's like a 1/10 of a millisecond past, which is really, really cool. So there we go. We now have an API endpoint to handle this incoming data. So once again, I can actually deploy this, which I will with Pnpm run deploy. I'll let this finish, and then we'll just test it in production in just a moment. A little over a minute, and it finished. I'm going to go ahead and open up the CloudFront endpoint here. And ideally, or hopefully speaking, we've got our ABC and ABC. Again, we've got our CloudFront here. I'm going to open up the console. I'm going to hit run join list. It's loading. And what do you know? There's my result. And also just as fast, or very, very fast, as we saw before. Fantastic. So we can do this over and over and over again. We now have a way to ingest data in production right into our database. It's fantastic. Let's keep going. Our current email form has a big issue, and it's something that's probably easy to just skip over based off of the success we've had so far. So let's take a look. If you go into forms.js and you change this input right here from the email to simply text, save it, and then come in here and do abc at abc.com, hit join list, and nothing's the wiser, right? It actually ended up working. But if we get rid of the email part of it and just run join list, that also works, as we can see down here. We could also verify this in our actual table itself, which I cleared out, but we see that abc at abc.com and abc. That's not good. We want to actually have a real email here. So that means our validation has some work to be done. So inside of our route.js, the API route, we can actually validate the data right in here. And so what I want to do is just get a clean and clear validation for that email. So to do this, I'm going to go ahead and install, we're going to install validator.js. So pnpm add validator. And then inside of route.js, I'm going to go ahead and import it. So we'll go ahead and import validator from validator. And then I'm just going to go ahead and say right next to unpacking this email, we'll go and say is valid email. So const is valid email equals to validator.isEmail. And then we just pass in that value. And now basically I can just say is valid email. If it's not, then a valid email is required. Very simple way to validate this and something you could use for a long time. So if we come in here and say ABC, hit join list, now I see that it says valid email is required. So that's a really good start in terms of validation. And the validator.js has a lot of other validations that you could potentially use, right? So if you came into the documentation itself, you can see all of these. Is Boolean, is before, base 64. There's all kinds of validations that you can do in here. Is a date, is a decimal, right? So this is really nice in the sense that, yeah, we don't have to engineer this ourselves. We can just use this is validator part right here. But the thing is, what if I actually wanted to add an additional field to my form based off of my schema, right? So based off of what I want to store in the database. That's logical reasoning. So if I wanted to add first name and last name in here, this new validator, well, maybe it just doesn't work anymore. It doesn't work for what's going on, which means that we need a little bit more of a robust solution for that. And that's why we're going to be taking a look at Zod. Zod is a way to do much better validation with Drizzle, and we'll take a look at that right now. Now we need a way to validate more of our data that's coming in. In other words, with my database schema, I have a few other fields that I might want my form to start to collect, right? If I want to put in my first name here, my last name, and then I want it to validate based off of the lengths that are in here, 150, for example, or if I changed it to something shorter, I want to make sure that those things are validating. Now, yeah, on one hand, in our route, we could go one by one field by each field inside of the route to do all of that sort of validation. But that's not what I want. I want to validate it all at once. So I want to make sure that all of this validation actually corresponds really well to the schema that I defined for our database. And to do that, we're going to be using Superman's villain called Zod. Just kidding. It's just a package that's really, really good, and it's going to be one of your best friends. Zod is awesome in conjunction with DrizzleZod. So DrizzleZod can actually help us create the Zod schema. Yes, it's called schema as well, but the Zod schema to actually do the validation that we need. And then we'll make it a little bit more human readable using Zod validation error. Okay, so to do this, we're going to go ahead and install a few things. So Pnpm add Zod, DrizzleZod, and then Zod-validation error. Add all three of those. Then we're going to go ahead and convert this lead table into a schema validation as well. So I'm going to go ahead and import it. So import the create insert schema, and this is going to be from DrizzleZod. Okay. So what I want to do now is that we're going to export the constant, and this is going to be our insert, and we'll call it our insert lead table schema, which we could think of it as a validator. We could call it validator, but I'm going to go with the documentation naming of it, which is just like this. So we're going to grab that original lead table, and that's all I'm going to do, just that. So this is now going to help me validate my schema, which we'll take a look at in just a moment. So going into our route here, I'm going to go ahead and import those schema values, very similar to like what I did with the DB, just like that. And now underneath the data, we can go ahead and say parsed data equals to await schema dot insert lead table schema dot parse of that data. And so we could console log this, parse data as well. And let's go ahead and do something like that. Okay, great. So back into my form here, I still have that input type of text that's going to be important for our testing. So if we come back in and I want to try out an email first, and we'll go ahead and hit join list. And this should actually work. Everything about this should work. And on our backend, we should be able to see that parsed data come through with that running server. And there it is, right? So that, of course, is coming directly from the parsed data based off of the schema itself, based off of this. But again, I still have that input type of text in here. So if I change this to ABC and join it again, it does say a valid email is required. But if I look at the parsed data, it's not a valid email. Of course, this ends up happening because of our route itself. It's still using that other validator method. We don't want that anymore. Let's go ahead and comment it out for the time being. So I'm going to use parse data now to unpack the email. and we'll get rid of this is valid data email. Now you should already know that this is going to cause some issues with our database. It's going to bring us back the incorrect data. So let's go ahead and fix that in the insert lead table data schema. What we can do is we can actually pass in some arguments in here to help validate that data. So these arguments are going to be the data points that we actually want to come back. For example, email. Email, of course, is the actual field that we want to validate and the field that we want coming back. So we can run a schema validation just like this with schema.email and then doing something like .email on it, right? So this now will require that data to be an actual email itself. So let's go ahead and run this again, and I'll do ABC just like that, and we'll go ahead and hit join. And now we get a 500 error, whereas on my server side, I see what that 500 error is. It's actually a validation error. So this is great. So it's actually showing us the validation error, but it's causing a server error. So of course, back into our route, what we need to do is actually handle that correctly. So to do this, we're going to go ahead and create a try catch block here. And what I want is I want to change the parse data just slightly to being let equals to parse data and make it just an empty object so that when this is unpacked, it's incorrect. So yet once again, I can then say, you know, if the email's not in there, then we're going to go ahead and give me that same email required part. But of course, that data should still be in here with this parse data itself. But if for some reason my schema is incorrect, the most important data piece of this whole thing will still be handled in some form. Okay, so this error function, though, is something else we need to handle. So to do that, we're going to go ahead and we'll get rid of this validator from here. I'll comment it out for a moment. We want to import Zod now. So we're going to go ahead and import, and it's actually importing Z as Zod from Zod. And what we want is we want to check what this error is. Basically, we'll say if the error instance of zod.zod error. Okay, so if it's a Zod error, then we will return back some sort of error response. If it's not a Zod error, then it's most likely a server error. So we'll go ahead and say some server error right here. Okay, cool. So now if it's a Zod error, we can actually update this to get the actual validation itself, which this is directly coming from that Zod validation error. So we can import the from Zod error from the Zod validation error package. And now I can come in here and say const validation error is equal to the from Zod error of that error, and just change the message to being something like error list. And that validation error right there. Great. So hopefully not too complicated at this point. Let's go back in here. I'll do ABC. I'll submit it. And there's our error list. And now it's got my details in here and saying invalid email, right? And it shows me exactly where it is and all that. So on my front end, I could handle this a little bit more cleanly and actually show that validation error. But that's not something I'm going to do right now because I want to look at the schema one more time to do a few other error like validations that I might want. So I can do something like min, as in a minimum number of characters. Let's say, for instance, 4, for example. So that means our email has to be greater than 4. I would say most emails are, but this just verifies that and validates that for us. Now we can also do another thing called refine. So refine is another way to do another kind of validation. So if we can pass in our callback function here, which is validation. And then we can also pass in our own error message, which would be something like message. Let's say, for instance, we want to say email must not be Gmail. Right? So in other words, if it is Gmail, we want to run that error. So this refinement has to be the opposite of what we want, basically. So how do we actually go about doing that? How do we make that validation? Well, one of the ways is using validator.js. So I'll import validator from validator. And now what I can do is I can say validator dot contains, and we can pass in the value itself, and then we can say gmail.com. Now we can say email must not be Gmail. Well, in this case, it's only going to allow Gmail email addresses, so I need to use the opposite of that with an exclamation mark. So now if I come in here and say abc@gmail, hit join list, what's going to happen with the error itself, I come back down in here. I should see that validation error and says email must not be Gmail. Fantastic. So I can do all sorts of validation on here thanks to Zod. Now, Zod has a lot to it, something that I'm not really going to be covering here. But if you go into strings, for example, you can see all kinds of things that you can do on strings. And the data we already have, which is going to be this data right here, is considered a string. So you see .email on there, and you can chain a lot of these things together. Not that you would chain email and URL together, but what you can chain is refine after refine after refine. You can do a number of these things, including like min and all that. So it's really, really nice. The other thing is if you want to have one of these other fields in here as a potential, you can bring it in. So what you do is you're going to bring it in very similar to what we just saw. So it's going to be like this. But now it'd be first name. And you would do something like min being, 2, and then the max being 150, right? And then also we want to make it optional. So you would use optional. So that is now not a required field. If we did not put optional there, it would be a required field and thus run a validation error right off the bat. So we go ahead and put last name in there too, and any other sorts of validation that you might want. So now our route itself will catch all of those validation errors and display them or send them back. So our front end would be able to display them as we see fit, which is great. That's exactly what we wanted. And we wanted this to be a little bit more powerful of an actual route, an API route, especially when it comes to ingesting this kind of data. It's pretty neat. Zod's great. So is Drizzle-Zod. Let's keep going. Now we're going to implement a GitHub action workflow to trigger our SST deploys. What this means is every time we push our code into GitHub, GitHub Actions will fire off a one-time workflow, like a automation process within a remote computer, and it will actually run all of the commands we need it to based off of our code. Now, I could show you exactly what to do, or you could go based off of some of the pre-existing or pre-built workflows that they have. So if you go into GitHub Actions, the tab in any given repo, and do a quick search for, let's say, Node.js publish, and just hit enter like that, you should see this published Node.js package. There's another one to GitHub packages. You can use either one. Both are actually going to be good references on what we want to do. So let's go ahead and configure it. Now I'm actually not going to write the code in here. Instead, I'm going to go ahead and copy all of it. So let's go ahead and do that. And I'm going to go into my local code project here. In Leads Landing, we're going to create a new file here with .work or GitHub/workflows. And then we'll go ahead and just call it main.yaml. And then we'll paste in that workflow here. Okay, great. So this is an example workflow, and the name I'm going to go ahead and give it is deploy via SST to AWS or something like that, right? Next, the on right here, we're going to go ahead and actually just change this to just simply workflow dispatch. This means that when I push it to GitHub, I'll be able to just run it right there. So every GitHub action workflow has the ability to run jobs based off of a specific trigger. This specific trigger is going to be this workflow dispatch on GitHub Actions itself, which we'll see in just a moment. Then I can run jobs in here. Each one of these jobs can run steps or their own sorts of code within that. And we can also use third-party or first-party GitHub Actions. We're going to be mostly using first-party GitHub Actions, as we'll see in just a moment. Now, the first thing is we need to actually check out our code. We need to get all of this code inside of the workflow itself. Now, the workflow is really just a virtual machine that's going to be running code for us, and it's going to use each step to set up that workflow or that virtual machine to make sure that it can actually run that code. So we want to check out the code. Then we want to set up Node.js, which is what this does. Now, what's really cool about GitHub Actions is we can actually review any of these first-party or third-party GitHub Actions triggers or plugins just like that by going to github.com/whatever it is. In this case, this is a first-party one, as in GitHub manages the entire actions/whatever in there. So in this case, we see that it says setup node, and then we have options for node version, We can use latest, we can use specific versions and all that. Which in my case, I'm actually going to put in here a string of 18.x. This just means node version 18, which is what we've been using, the LTS, the current LTS. So what this does is just configure our environment to then run everything else. So what we need to run is, well, a number of steps. That's what we'll replace here. Now what we could also do is we could actually make a whole nother job where it does a lot of the same things all over again. I'm not going to do that. I'm going to go ahead and get rid of that other job and really just stick to one itself. I'm going to rename this job from build to just simply deploy. Okay, so with this in mind, I'm going to go ahead and get rid of or comment out those two things and just have this as my action just to bring it into my GitHub account. So let's go ahead and create a new item here. We'll do git status, or actually we can add it in here. And we're going to commit it, and we'll go ahead and added new GH action or GitHub action. Commit it, and we'll sync those changes. And then we'll go ahead and take a look at GitHub directly. So I'm going to go ahead and navigate away from the one that I originally was working on and go ahead and say OK. And there's my main.yaml. Cool. Not a whole lot of surprises going on here. But if I go into the GitHub Actions tab now, I see something quite a bit different, right? Now, of course, if I go into new workflow, you could probably get back to where a bunch of examples exist of different workflows you can run. So in here, I've got the one that I just named, deploy via SST to AWS. And I can click it. And notice it says this workflow has a workflow dispatch event trigger, which means I can just have this little button here and go ahead and run it. It's really just that simple. So from beyond this, what we want to do is we want to actually run a number of steps, right? So inside of my steps here, I'm going to go ahead and create a new one. I'm going to give it a name. And the very first thing I need to do is I need to install Pnpm. And if you remember what it is, it's simply run, and that is npm install -g pnpm. Now, we also might want to upgrade npm itself, but we probably don't need to because we're going to use pnpm instead of npm. So once npm is installed, then we want to run the install deps or dependencies basically for our project. And then I'll go ahead and run the command that you might already be familiar with, which is just pnpm install. And that's it, right? So from there, we can then start running our various commands, which would be, let's say, for instance, this would be install AWS creds, and then we want to have something for the pnpm run deploy, and then maybe also, name and set SST config secret or something like that. We'll come back to each one of these things in a moment. But the idea being that we want a very simple workflow that's going to run each time, and it's going to do each one of these commands sequentially. And if any of them fail, it will stop in its tracks. So if we look at the workflow dispatch itself, this one probably shouldn't take very long to actually run, right? So it's just doing the cleanup action right here, which is for some reason taking a while. But everything else took only a few seconds. So these are all of the ones that I actually declared, and then everything else is just taking a little bit longer than expected. Great. So what I also want to do is I'm going to go ahead and add in a new trigger, and I'm going to call it push, and then I'll go ahead and declare my branches that I'm going to be pushing on. In this case, I'm using main, so you might have master in here as well, so you can put both of them. But now with this new trigger, these jobs are going to run whenever I push these branches. So if I do git status, either way, either directly on the command line or right in VS Code, we'll go ahead and say updated GH workflow. We'll commit it, we'll sync it, run it, and go back into GitHub Actions. What's going to happen in a few seconds is it's actually going to trigger that workflow. And there it goes. Okay, cool. So this is getting started with GitHub Actions, right? So we need to make it more valuable than this. At this point, it's not really that valuable other than the fact that it's showing us everything that needs to happen. It's going to install Pnpm, then it's going to install all of those packages based off of the lock file, and it's going to run all of that configuration. And then, of course, we still have our other commands that we need to run. But the really nice thing about this is it's very consistent. It's always going to go based off of this, which is exactly why we're going to use it. Now we're going to go ahead and implement the AWS of it all and then actually run that deployment. With AWS means that we're going to be using GitHub Actions secrets and brand new AWS configuration or actual secret keys and all that. GitHub Actions is another computer that will run our code on our behalf. That's really what it is. It's a completely separate environment from our local machine. So what we could do is we could attempt to use SST to actually run the deploy and see what ends up happening. So we're going to go ahead and just run that. So Pnpm run deploy. So rather calling it that, we'll call it deploy with SST, or maybe deploy to AWS with SST, something like that. We'll go ahead and save that, and we'll do git status, git add, git commit, deploy to SST, and then we'll push it through. Okay, so I'm going to let that run for just a moment because it should fail, and we'll take a look at that. But one of the other things that we might consider on this workflow is to only trigger the actual push, when certain paths change. So this is another thing that is definitely worth considering. So let's say, for instance, our SRC path, we want all of the files in there to, well, trigger a new dispatch. So this will be that pattern for that. This means that anything inside of SRC will trigger a brand new run. We could also do something like our GitHub workflow itself. If we make some changes to that, perhaps we want it to trigger a new run. And if we want to change anything else in here, like if the JSON files change or the YAML files change, we could also run all of that. Now, you could definitely modify this how you see fit, but the idea being that if we do a push, it should have some major changes to it before it actually runs the workflow. If there's no changes whatsoever to these main things, then we probably don't want to run it. In other words, if we go into like README and we change a few things, probably aren't going to need to have our workflow run. Almost certainly won't need to. And we also might want to be more specific than this as well for any given workflow, because we can have as many as we'd like. Of course, costs might start adding up there, but everything we're doing here is free, or will be free for some time as far as I can tell. Okay, so with that in mind, let's go ahead and take a look at the failure that should have happened in our GitHub Actions. It's still running, so it's taking a little bit of time for it to fully fail. But what's going to happen is it just won't have permission or access to AWS or to our account. I'm not even sure what it's doing here. I'm surprised it's not already failed. So we're going to assume that it's going to fail, and we'll continue forward by adding in a couple secret values inside of our repository itself. So in the repository, under settings, go to secrets and variables here, and we're going to go into actions, and we're going to create a couple repository secrets here. So before we can even create them, we need to go into AWS and go to IAM, and we're going to grab our IAM resources here. And then I'm going to go ahead and look for my different users. In this case, I've got my leads landing user. Now we can use that same user, or we could actually go ahead and say leads landing GitHub Actions user, and basically do the same thing that we did before. So add user to group. This time it's going to be our Next.js SST group right there. And then we'll go ahead and copy that, create this user, and let's just verify that that's the correct group with our permissions in here. And we've got our SST policy. Great. So back to our users, we're going to go ahead and grab our GitHub Actions user here, go into our credentials, and we're going to go ahead and create these access keys. Now I'll go ahead and say other and next, and there's going to be just GitHub Actions creds, create those there. We're going to grab the access key here, and we'll bring it into the password here. So the common way to do this is going to be AWS Access Key ID. That's going to be the common variable name. But the actual variable name that you use can be different than this. But whatever you end up using here, we need to reference once again. So inside of my main.yaml here, I'm going to go ahead and bring in that install creds, and we're going to go ahead and run some commands here. Use that pipe to have multi-line commands below here. So what I need to do is I need to create those credentials. So this means that I'm going to run something for echo AWS Access Key ID equals to $, 2 curly brackets, then it's secrets dot whatever name I gave it, right? Which is this right here. That's the name I'm going to give it right now. So let's go ahead and add that in. And then the next one is our secret access key. So I'll go ahead and copy that one. We'll go into bring a new repository secret here, AWS secret access key. Now, once again, I'm just going to copy the name here, add this secret, go back into my workflow and echo, this is going to be AWS secret access key, and it's going to be equal to basically the same thing. Let's make sure we have everything correct here. So this will install my credentials almost. But what we need to do is we need to make a directory for this at .aws. Then we're going to go ahead and echo the default profile. Remember when we did this? And this is going to go into AWS/credentials. So what we're doing here is we're actually overriding the default credentials that might be in there. There probably aren't any, but if they are in there, it's going to override it with just this one single greater than sign. If we actually do 2 of them, then we can append it. Hopefully you know that, but now you do if you don't. And that's it. That's actually how I can set my secrets for these credentials. Now, there are almost certainly third-party packages that can add in or install your AWS keys to use the AWS command line tool or the CLI, but we actually don't need that. Instead, what we can do is just install those credentials, and then we can run that deploy command after they're installed. Remember, the deploy command itself is going to go based off of that default profile because that's what we set up. That's what we configured some time ago. And so we can also run our various, SST config secrets. And that, once again, is something like run, and then we did npx SST secrets set, and then some secret name itself. In my case, I'm going to do something called the commit SHA, which I will just copy and paste in here. So you can use these GitHub variables. There's a bunch of different GitHub variables you can use in there. And then I'm going to apply it to this production stage for this particular project. And that's it. So you can add all sorts of other secrets in here with SST. You can do multi-lines, and you can set it up very similar to these secrets that you did right here. So like if you needed to update your database URL, you could do it here, right? And so we'll take a look at that in a little bit. But for now, we are just going to leave these. I'll go ahead and say git status, git add, git commit, and installed, let's say, AWS keys. Before I push it, let's go back into GitHub Actions, and let's take a look at our failed deployment. As I knew it would happen, it happened in about 2 minutes. And we see in here that, let's scroll down a bit and say something like, could not load credentials from any providers. Great. So now let's go ahead and push it. And once again, this will run. And if we spelled everything correctly here and we put it in the correct location, we should be in good shape to actually use the AWS credentials right inside of SST, just like we saw before. So going back into our actions here, I'll let this finish in just a moment. Now, one of the biggest things that I really like about GitHub Action workflows is they help us understand all of the steps that need to happen in order for our application to be whatever. In this case, it's deployed, but perhaps it means built, perhaps it means tested, perhaps it means staged. You can insert anything in there, and this is basically a tutorial of how all of that happens. Of course, you still need to understand the context, like you need to understand that this will call a specific package and how it sets it up and how you can use it. But just generally speaking, that's what I really like about these workflows. So if we go back into our workflow here, this, in my experience, has taken a while only because of this deploy here. So there is one more thing that I do want to add in my workflow just to be extra secure, and that's clean up our AWS profile. And that really just means that we're going to run the rm-rf of that AWS folder. That entire folder there, mostly just to delete it in the workflow right when it happens. So it's something that I definitely get in the habit of myself, is if I inject keys of any kind, I want to go ahead and remove them towards the end once they are done and used. So we'll come back once this is finished deploying and we'll take a look at how long it ends up taking. This, in my experience, is where it ends up being about 10 to 12 minutes for this to fully deploy. And there we go. After about 2 minutes and 30 seconds, it did a full deploy. Now, one of the things we can see here is the deploy to AWS. We can actually scroll to the bottom of this. We can also see all the logs and everything that happened, but we can see our actual site URL, which we could always open up and take a look. There it is. So I just want to do a quick change and change this from CloudFront. Let's go ahead and say GitHub Actions there. So instead of src of our project here, we're going to our page and we'll just call this GitHub Actions. There we go. And so we will come into here. We're going to add both of these items in and we'll go ahead and say updated for GH. Hit commit, sync changes, okay. And so once again, I will let that next deployment go. But the idea here is we now have an automated way to deploy everything. Yes, we could still do it locally, but the thing is, I probably want to work away from doing it locally and just do it in GitHub so that it's my single source to deploy. So the other thing about this, if we think about it, if we start adding a bunch of production level secrets on GitHub Actions, we want to make sure that those are happening there. And we also might want to have our migrations run here as well. That would actually make a whole lot of sense to ensure that our migrations are there before we go into production, right? So running the command that we have for migrate right there. And in the migrator, we also might want to have multiple stages in here as well, depending on if our stages have different databases for them, as they often do. So with this in mind, let's go ahead and see where our GitHub Actions repo is at and see if it's going to be done. I'm going to go ahead and pause it and come right back. Okay, once again, it finished. I already have the production version up and running, so let's do a quick refresh, and there we go. Great. So we're in a really good spot to go from code to production with GitHub Actions. Of course, there's still a few things that I want to improve, so let's take a look at how to do that now. Now we're going to go ahead and add in caching into our GitHub Actions workflow. Now this should help build and deploy our application as it grows in complexity. That's really the goal here. So to do it, jump into your GitHub Actions workflow here on your local computer, and we'll go ahead and say name, and there's going to be cache Next.js build. Something along those lines. And this uses actions/cache at v3, or the version 3 of this. And it's going to have a few arguments. First off is the path. Next is going to be the key. And then finally the restore keys. Okay, so the key. Let's start off with this, and we'll go ahead and say cache-Next.js. And then our restore keys will be basically the same. And then our path, what we want to do is the path that we're going to cache. What is it that I'm trying to cache? Well, in this case, .next, .openNext, and .sst. Those are the paths I want to cache. That's because whenever I've been running build or deploy, these things get updated. So I'm going to go ahead and keep them updated inside of my GitHub Actions workflow. So we'll use next here, and then .open-next, and then .sst. And it's really just that simple. But the thing that I actually want to update and change as well is the actual key itself. I want the key to be based off of what's going on with the files so that I have a history of caches, not just the most recent one, basically. So to do this, I'm going to go ahead and use a built-in function to GitHub Actions workflows, which is called hash files. It's just like that. I'm going to use it twice in here, and then down here I'll use it just one time. So the idea being that we are going to hash files. We're going to basically take the file itself, some of the contents about it, and hash it into just a string that then gives it some uniqueness. So the main one, the one that I want to start with, is pnpm lock. So I'm going to go ahead and use single quotes here and do pnpm-lock.yaml, and this should be *//. Make sure you're using camel case here with hash files, but basically anytime pnpm lock changes, I want to make sure that the actual workflow itself knows about it and will create a new hash for me. With that in mind, I also want to go ahead and hash all of the JavaScript files that might change with *.js. Or I can use the TypeScript one as well, and I can use this bracket to be JavaScript or TypeScript ending with S. And then taking that same concept, we're going to go ahead and do JSX and TSX, just like that. Great. So this will create that hash, and then this restore key will look for the latest of whatever that hash is because it's using the same prepended value here. And it's just that simple. So with this in mind, let's go ahead and say that we are going to do our build cache with GitHub Actions, and we'll commit it. Yes, and we'll go ahead and sync those changes. I'll let it run, and we'll take a look in just a moment. Now, the idea here is you probably aren't going to have to do this for every project ever. This is really just about speeding up some of the already cached things on our local machine so that it actually works in our CI/CD. Now, in some cases, we might not need all of these things. Maybe we only need next cache, and maybe that would actually suffice, and then that way we just change our cache to be that specifically. And then, of course, if you had different operating systems and stuff like that, there's ways to iterate through this based off of those operating systems too. But this is just a fundamental way of using that caching. So with this in mind, let's go into our workflow actions here. And I got a build cache error here. Unexpected symbol. Let's go back in here and take a look as to why. And let's go back into our workflow. I think these need to be single quotes. So let's change them all to single quotes here. And we can get rid of that trailing comma. Okay, so now with that in mind, let's go ahead and say removed double quotes, commit it, sync those changes, run that again, and back into GitHub Actions. Let's take a look here. Remove double quotes. So far, I don't see any major issue, but let's go ahead and let this go. Great, so no major issue, and it also shows us the input keys. So cache not found for the input key. So this is what that hash files does. That's the hash that is created. And you can do it with the cache as well. So both of those should be the same, the first two. And of course, it can't actually find anything for this because we haven't created this cache yet. So one way to go forward now would be just to continuously run it again, and then it will be able to find that cache. I let it finish, so let's go ahead and rerun it again. I'll go back into my actions here, and we'll give it a run. And this time it should find that cache. So it should be at least a little bit faster than it was previously. It's going to be like incrementally faster, and it actually hasn't been taking that long. But it's going to be a lot faster when we go to build it in the future with a much more complex project. But the main part here is just really to see that we do have that cache. And there we go. There's the cache right there. So it's restoring from that. It's going to do the installations and everything else. Cool. So now that we have caching involved, let's go ahead and bring in a new workflow for staging our application to have a completely separate stage with a separate database so we can verify everything's working the way we want it to. And while I love deploying into production, it's always a good idea to have a staging environment, a staged environment that is almost production. It's like pre-production. It's like those last final checks to make sure everything's running correctly. And that's what we're going to do now. We're going to actually stage a new version of our application using SST and using a really cool feature from Neon. So first things first, we're going to go into our GitHub workflows here, and I'm going to duplicate main.yaml, and I'm going to call this stage.yaml now. Main.yaml, I'll just go ahead and have it only run at workflow dispatch. And I'll call this my one-off deploy now. I'm not going to keep it as a regular deploy, but rather just a workflow dispatch deploy, and mostly a reference for you at some point. In stage.yaml, we'll go ahead and call this our stage deploy, or rather our staging deploy. Now, the reason I'm calling it staging versus stage, it has everything to do with SST itself. SST has a flag called stage, so we're going to just use staging as a stand-in for the various stages, right? So we got a staging version and then a production version, and those are the only two versions we'll end up having for us. Now, and then of course we've got our local version as well, but that's like a development version that we're not really going to be touching at this point. So the idea here is we've got our staging version, And this is going to do, well, basically everything we've just done, except we just need to change the actual SST stage from just stage production to simply staging. And overall, this will work generally okay, except for the deployment part. So we go into our package.json, and we actually have one for deploying a staging version. So I'm going to go ahead and bring that in as well. So Pnpm run deploy staging. Now, you might already know this is going to cause an issue with our database and probably our migrations for that database. So again, in our database itself, we've got our config.database URL. So we actually need to have a database URL for that stage. Now, we can use the production version if we wanted to, right? But I don't want to. I want to use the stage version. I want to have a different version of my database in the staging process so that I can make the migrations, make sure everything's working okay there before I actually commit this into production. So we'll now go ahead and set a database URL right here. And we're going to use GitHub secrets to do this. So it's going to be secrets dot. And in this case, we'll do database URL underscore staging. That's it. So we need to add this secret in. So let's go ahead and jump into our GitHub repository here, into settings, and then into our secrets and variables, actions, new repository secret. Let's go ahead and bring this one in. So where does this database URL staging come from? Now, of course, it comes from Neon itself. Now, what we're going to do here is we're going to jump in and we're going to create brand new connection details for this, which means that I'm actually going to branch the database at this point in time. So I'll come in here and we want to create a brand new branch for this database. So click on branches, click on new branch, and this will just be our staging branch. It's from our main branch, and we'll get it at this current point in time where that database lies. And I'll go ahead and create this branch here. And there is my new staging URL. So I'm going to go ahead and copy that, bring it into my action secrets, go ahead and add that. Since we added the database URL staging, I'm also going to add the database URL. So I definitely want to have both of them because we want to also automate a couple processes from this. So I'll go ahead and copy both of these database URLs and save it. Okay, great. So this database URL is mostly for the production one, which we'll do next. But for now, we have our database URL for staging. And so this is mostly ready, but it's still missing one step, which is going to be doing the migrations. So run db migrations with the stage, or with staging, or let's go ahead and say run staging database migrations. That's probably better. And then we'll go ahead and run. Well, what do we need to run here? Well, going back into package.json, we could use something similar to package.json where we have migrate staging, just like this. But I'm actually going to use TSX directly to ensure that it is working and it is migrating. So what that means is that we will grab this TSX migrator and we'll run it just like that. So it has to be after the secrets. That's actually really important. Otherwise, we might not have the correct database URL or, other options that might happen. So we want to run these migrations before we deploy it. And we also need to, think about the stage once again. So if you remember back to the migrator.js, I did have in our get secret rather. So in get secrets, we did have this stage variable here from the environment variables. Now I did this for this particular spot, is that I can actually put in that stage before TSX. Now, yes, we could probably add arguments and parsing arguments and all that. This to me is just so much easier to do that. And it also declares the stage right directly in there. So it's fairly straightforward as to what's going on, hopefully. And so that hopefully is it. I don't think we'll need necessarily anything else. So let's go ahead and give this a shot. We'll go ahead and do git status. We see that those two things changed. Using VS Code, I'll add them both. And we'll go ahead and do staging workflow, commit it, and sync those changes. We'll go ahead and say OK. So the staging workflow should trigger off right away. And it should actually give us a different version of our application. as in the original production versions should still exist and not really change whatsoever. So of course, this is really just setting the foundation here. I'm gonna let this finish and then we'll come back. And we get the error tsx command not found. This of course is because of how we actually ran that. So let's go ahead and fix that. And this should be npx tsx, all of the migrator stuff. And this would make sense to actually put it back into package.json. I'm not gonna do that right now. The other thing I need to change is the actual trigger for stage.yaml to make sure that that's actually running as well. So we'll go ahead and update all of these, and we'll go ahead and update stage workflow, commit, and sync those changes. And let's go back into GitHub, into our actions, and it should run the trigger now. There it is. And so I'll let this do its thing. All right, so this time around, it went through. Everything's looking good. The migrations were performed, which we'll check in just a second. Actually deploying this will take some time because it's going to be the first deploy of this stage. So it's got to do everything it needed to do for that first deploy. And so back into our console here, if we look at our tables for the staging branch, we should see our leads table in there. Now this should have already been in there, right? So it should have already been in there because of that branching. That migrations will happen if I make changes here and then push those into the stage. But if I didn't branch it in the first place, it wouldn't have that table, but it's coming directly from the main branch table, which is cool. It's very good in the terms of how we want all of this to work. So I'm gonna let this actual deployment stage finish. Should take, I would say, anywhere from 5 to 20 minutes, maybe even more than that, in part because of how long CloudFront can take to distribute everything everywhere. But of course, while that's being deployed, we see that the CloudFront function was created. So maybe we already have it in our CloudFront distributions here. If I refresh, I don't actually see it yet. Once you see it in here, that will be a good indication as to it's like close to being fully done. All right, so my staging deployment ended up finishing, so I can go to the URL itself right here. You could always go into CloudFront as well and then find the staging leads landing, version, and then look at that URL also. Now, one of the things that's important about staging is finding bugs. And right now we've got one. If I go to /API, I've got an internal server error. So this particular bug is, fairly easy to suss out. The first thing that I would end up doing is checking or thinking about what are the dependencies that I forgot. And that's going to be our configuration secrets. So if we go into, let's say, for instance, SST config, we've got this secret val here, but I actually never set it on this stage. We did it before because we've been learning about this, but I want to make sure that all of those secrets are definitely in there. Now, you might have already thought about doing that when you did this block, and if you did, good for you. If you didn't, that's okay. It's an easy thing to overlook, especially because, this secret val is not something we'll actually use. But I'll go ahead and add it in anyway. I'll leave it as the GitHub commit SHA. But now that we've got this, I can also just do this locally, right? So if I do it locally, does it solve the problem for me? So secret val, some val, and then we'll go ahead and do our stage here. And then of course is going to be staging, hit enter. And then if we go into our API here, shortly after I do the API, not right away, but shortly after, this 500 error should probably go away. Notice, of course, the page isn't working yet, so it's not fully ready. So it might take a few minutes to get that fully up and running. But in this case, it took like 30 seconds. And there's that secret value coming through. And so now if I go back into the home page here, let's try to do ABC, or let's do live at abc.com or something like that, right? So just a test email here and hit join list. And in theory, this thing should work. It's possible that it doesn't. So let's go into our console here. We got a 400 and we got an error, Zod validation error. Must be Gmail, must not be Gmail. So I got a validation problem. So perhaps I have the incorrect, maybe it is actually only Gmail. Yeah, so we've got a validation error that we're going to need to fix. And I'm not sure why that's happening, but of course, this is what happens. We get errors. So let's take a look at that now with our validation schema. So we've got a route here, insert schema, parse data, and there's our validation error. So back into schema here, we've got must not be Gmail. So this refinement, I'm going to go ahead and get rid of. That was mostly to learn about it. I'm not sure why it's doing that specifically, but I'm going to go ahead and get rid of that. And now we've got two things that we needed to fix. So we'll go ahead and do git add -- all, git commit, and updated validation and secrets. And then we'll go ahead and push this into our project. And of course, this is going to trigger off that stage YAML workflow with all of those changes, so that once that finishes running, we will be able to review those changes to make sure that we've got some issues solved, right? And hopefully this time when we actually deploy, it's going to go much, much faster. And so what I want to do here is I want to actually add one more step that will trigger a pull request. So part of the reason we solve these problems sort of manually, sort of automated, is to have an automated trigger for the pull request itself. Basically so that then I could go in and approve it, or somebody could go in and approve it to be moved into production. So now we're going to go ahead and take a look at that action. At this point, it finished. So if I refresh in my application here, hopefully what we'll see is ABC at ABC working. I'm going to go ahead and load that in. Looks like it worked. I'll go ahead and change it to live 123 cloud front. Hit join list. And again, it seems to work. Back into the Neon console, into our staging branch under tables. If I refresh in here, what I should see are those new values, and I've got a bunch of them. What I do not see is in main, my main branch does not have any of those, right? Once again, this branching is fantastic, and also the staging, we now have a way to, well, basically use our production database, but just slightly modify it a little bit so we can fix errors or issues that may come up, which is great. It's not touching the original database at all. So the last piece of this is to then submit that pull request, actually create it. So to do this, we actually create a new stage here. I'm going to do it after basically everything. Everything is complete. So this stage, we're going to come in here and say name, and we'll go ahead and do create pull request to prod or production. Okay. So this means that we're going to go ahead and run this if everything is successful. So everything prior, we're going to go ahead and run that it's successful. And we also want to pass in a built-in environment variable called a GitHub token. And this is just simply secrets.github token. This will work on our workflow directly. And then we can go ahead and run the GitHub command line tool that's also in our workflow. And it's going to create from a new pull request, the base of our actual branch name, which we're going to call production. And it's going to come from main, the head branch of main, which is our current branch. This is going to be our staging branch as well. Then we're going to go ahead and give it a title of stage changes or something like that. And then we'll give it a body with auto PR from stage release. Something like that. Okay, so this right here will automate the process of creating a pull request, which means that I actually need to have the production branch already. So I'll go ahead and do git checkout -b production. This will check out the code into the production branch. You only have to run this one time, because here on out now, all of the code will be either in main or in production. So we'll go ahead and go back to git checkout main, and then we'll go ahead and do git add stage, or rather git add period, git commit, updated my stage workflow. And then before I push it, because this will automatically trigger everything, I'm going to go ahead and do git push origin production now versus origin main like we've seen. So I can actually push that branch in there. Notice it's saying create a pull request and all that. So back into main, or rather back into our GitHub, we can see our two branches in here now. So here's our production branch, and then here's our main branch. What's not going to happen on our production branch right now is any workflows being run, right? So stage.yaml doesn't have production as a workflow that it will run. Main.yaml also does not, right? Only stage, or rather the main branch, is the only one that's going to end up running automatically. So in order for this part to work, we have to make a change to our actual settings in our particular repo. So in our settings here, we're going to go ahead and go into Actions, General, and what we want to do is scroll down to Workflow Permissions, and we're going to go ahead and do Read and Write Permissions and allow GitHub Actions to create and approve pull requests. We'll go ahead and save that. And so I want to make one more change here, and that is in my main branch here. I'm going to go ahead and go into page.js. And now I'm going to go ahead and say this is my stage leads landing live, just to make sure that that's working. So now we will have differences between our staging branch and our production branch, at least a simple one. So we'll do git status, git add, git commit, and we'll go ahead and say updated stage index page. And we'll go ahead and do push. I should probably say staging, but I'm thinking in terms of stage and production, as in staging is the stage, if you will. Okay, so back into my code. I can again verify these two things are different inside of my src. Let's go ahead and actually do git push -- all if we need to. Everything's up to date. Okay, so back into app and page.js. This is, of course, the main branch. We see stage leads landing live. We go into the staging or the production branch. It still says GitHub Actions leads landing live. Great. Next, of course, is my GitHub Actions themselves. This, of course, is updating that page. So this deployment process is probably going to take about a minute. It doesn't take that long. It could take up to 25 minutes based off of actual CloudFront distributions. But all of the tests we've been doing so far in this series have been about a minute to do all of that. So I don't think it's going to be that much different here. It could, but if it is, then we'll come back once that's done. But the main thing is I just want to see what happens on the stage itself. I just want that to change, and that's the point. And then we'll go ahead and see also the pull request that will come through in here as well, assuming that the actual workflow ended up working. So I'll let it finish and then we'll come back. And the workflow is nearly complete. The deployment happened in a little over a minute. Then the pull request to production also happened. No errors there. And of course, the branch itself already existed. That's a key part of that. It already existed on GitHub. If that branch didn't exist, we would need to create that branch. Okay, cool. And so I can also go into the app itself, refresh. What do you know? There's my stage leads landing. Now, before I even look at the pull request, let's go into the production one, the one that I've had all along. And we can now compare the two. And I've got GitHub Actions leads landing and stage leads landing. Fantastic. Next thing, of course, is my pull requests in here. I now have these stage changes, and there is my pull request, right? And I could probably take a look at the differences between all of the code in here. So updated stage workflow, what do you know? There's that code. Updated stage index page, what do you know? There's that code. And so I can now close this and then trigger off another workflow, which is what we'll do in the next one. But the main thing being that I can now have a staging environment that has a production environment. And yes, we could have a lot more things going on with these stages, like the actual repo itself or the actual URL itself. We could we could put in the body itself the URL from the deployed stage. That is something we could absolutely get. But before we ever think of anything like that, what I want to do is basically allow my pull request, once I close it and approve it, it will actually trigger a workflow for us for our production application. Now, what's also kind of cool about this is I don't actually have to stage my application in order for this to work, right? I could just get rid of this deployment altogether, and then now I have a pull request that went through a bunch of different processes that I wanted to have happen in order for the pull request to be fully ready for production. Now we're going to go ahead and create a GitHub Actions trigger based off of a merged pull request. Now the idea here is we see that it says merge 2 commits into production from main. It should not be the other way around. It should be from main to production. Again, thinking of main as our staging branch, production being our actual production branch. So to do this, we want to come back into our GitHub Actions here. And I'm going to go into main.yaml. I'm going to go ahead and copy and paste this, and we'll call this production. And the job itself I'll call production. And then now deploy production via SST. This time I'm not going to have a workflow dispatch. I want it to be based off of pull requests directly. So to do this, we come in and just say pull request, and we add in our branches. So the branches are going to be based off of the ones we want this to trigger on. In our case, it's going to be production, and the types itself are going to be closed, as in we want the pull request closed to run the various jobs. So to actually run this entire job based off of that happening, and if it was actually merged, we can use an if statement in here, and we can use github.event.pull request.merged equals to true. This will then trigger off the rest of that particular job. If it's not merged, we could do all sorts of other things as we see fit. So at this point, we basically have everything we would need to have this go into production. We set up the new commit shot there, and then we run deploy, and then we clean up that profile. So this is the same as it was before as main.yaml, but now it's based off of just those pull requests. Now, one of the things you might consider doing is removing the stage altogether. So this would be, of course, our SST command, so npx SST remove, and this is going to be stage of staging. So that might be something you want to do. So we say remove the staging deployment. Now, the reason I am not going to do this is because it does take a long time, and we have a number of huge benefits already for having this staging application, but also everything we're using. We are using a ton of serverless, right? So our database itself, serverless. Our actual application, the backend itself, serverless. The only thing that's really maintaining is CloudFront, and even that doesn't cost much until you start getting a bunch of requests. So basically everything scales based off of demand. So it really doesn't make sense to remove the staging branch or the staging environment ever, right? So we can actually keep that off, but it is nice to know that we could do it at some point if we wanted to. So the cool thing is, now that we've got this, let's go ahead and do git status, git add, git commit, and added production workflow. And then we'll go ahead and push this to our repo. And at this point, we shouldn't have anything running. It shouldn't have happened automatically. And then we've got this deploy here. Nothing's happened. And notice I cannot run it. Great. So going back into my pull requests here, I'm going to go ahead and approve this. We're going to go ahead and merge this, and we'll run that merge. And once that finishes, I go into my actions here. Notice it says stage changes, and there we go. So it's starting to run this workflow. And at this point, we should feel very confident that this workflow works, right? Because we've done it many, many different times. One of the things that we might consider doing is actually running a pull request and not merging it, canceling it. I'll let you do that on your own time, but the idea being is just run to make sure that this production one is either working or not working. And of course, the CloudFront distribution is what we'll end up looking at once that one's up, which right now says GitHub Actions leads landing live, and we will let this finish so we can see that one. It shouldn't take much longer. All right, so my production event finished, and if I refresh now on my production CloudFront, there it is, stage leads landing live. Fantastic. So we now have a really, really solid way to deploy our staging application as well as our production one based in GitHub and GitHub Actions. So now let's go ahead and actually clean this up a little bit so it looks a little bit closer to what we want for production. Now let's go ahead and turn our landing page in from this to this. Now we're going to do this using Tailwind CSS. which we initialized when we created our Next.js project. We're also going to be using a resource called Flowbite. Now, to me, Flowbite is a great place to find all sorts of example Tailwind components that you can really just copy and paste. So you don't actually have to learn that much of Tailwind to get the result that we're after. Now, I do recommend learning Tailwind and learning more about CSS, but getting the result is what we're after here. So let's go ahead and go to flowbite.com, go into blocks, go into the hero sections here. And you're going to grab the first one there, and then we're going to go ahead and look at the code for this hero section. Okay, so there's a lot going on, so I'll just go ahead and copy this code, and we'll go ahead and navigate over into our application. So basically what I want to do is in page.js, I want to replace it with this hero. So in my lead capture, I'm going to make a new component, and I'll call it hero.js. This is where we're going to actually do it. So I'll go ahead and export our default function called our hero landing page, and it's going to return back all of that code. So one of the things with copying and pasting HTML classes like this, this is not how we actually write classes in React. So I'll just do a quick Command F, Command and replace, to change it to class name and replace all. Okay, so that should solve some of those issues. Next, what I'll do is actually go into page.js. I'm going to get rid of basically everything except for page.js, or this hero landing. So let's go ahead and import this. I will come back with the capture form in a moment. So import the hero landing page from and app and lead capture and hero. Okay, and there we go. Come back into our project. It already looks quite a bit better. Okay, so maybe we don't want this hero. Maybe we actually go back into Tailwind or Flowbite, either one, and we scroll down a little bit. And now I see one that I think speaks a little bit better to what we're trying to do, and the fact that I can actually put a form here. Now, yes, there are premium options in here as well that you might consider, but what I want to do is just grab this one. Okay, so I'll go ahead and copy this, and we'll go back into our hero, and we will paste this one in. So let's get rid of the whole section here. There we go. And once again, I'll do that search and replace, save that, and go back into our project. It looks like we don't have a closing tag in here somewhere. Looks like maybe for the image, we need to put a slash there as well. Okay, so once again, that looks better, a lot closer to what we're after here. So now what I want to do is basically say the div here, which has the speak to sales and getting started buttons. I want to get rid of those. Okay, so now they're gone. And I want to bring back in my landing capture form. So I'll go ahead and actually bring that now in to my hero and put in right here our landing lead capture form. And there we go. So far, so good. And so if I break this down a little bit, I see that it still is working. The actual styles, the background is not looking that great. So let's go ahead and go into our global styles here, global.css. And I'm just going to go ahead and get rid of this body here so that it actually doesn't repeat like it was. Great. So the next thing is back into my page. I'm actually going to go up to my layout.js, and I want to change the class name just slightly. So I'll go ahead and leave that inner class name. We don't need to modify that right now, but rather just add in one thing, and that is going to be px4. So this just adds padding on both sides, just cleans it up a little bit. Next up, the payment tools for software companies. We don't need that. Rather, we can say whatever our heading is going to be. So this is going to be a landing page for sales leads, and something like using Next.js to deploy to AWS with Neon. There we go. A lot closer. And then, of course, maybe something like this image is not really what we want, but I'm going to leave it in there just because, well, we don't need to change everything about this. I'll leave that to you. Next up is going to be our actual image, or the actual form itself to collect everything. what we could do is we can come into Flowbite again and then go into forms and navigate into the forms. And I can see this input right here. So this input has a class already associated to it. So I'm going to go ahead and copy that entire class. And we'll go back into our globals CSS. And I'm going to do something called @layer_base. And now I'm going to do the input itself with that class that's coming through. So the input, going back into the form itself, is input type being text. It should actually now be email. So we'll go ahead and use input type of email or input type of text, either one really. And then we will use the selector. This is a very common CSS selector for something right there. And then we'll go ahead and put these curly brackets around the styles or all of the classes we want to apply to this particular item. Okay, so the syntax editing doesn't look that great, but let's go ahead and take a look at our form now. And there is now our email. Great, this looks a lot better. Next up, of course, is going to be the button. So we can use that same submit button if we'd like. And we'll go ahead and just grab those classes again. And this time I'll do a custom class. So using those same classes, I'll come back in here and we'll do btn join and then apply those same classes. And so now I can just copy this, go back into my form, and the class itself is just going to be simply that btn join. So we save that and we refresh in our app. There's our join list there. We still have a bit of spacing here. This is that space X that's going on. I could get rid of that altogether. And there we go. Now I might want space Y actually. So let's change it back to being space Y. So it's like top and bottom spacing basically. And there we go. So now I have at least a better looking landing page, I think, for all of everything that we wanted to do in terms of the landing page styling. Of course, you can always build on top of this, and I think it's well worth it by going into the various components on Flowbite. Maybe you want the features in there or call to actions, right? So all of these things that you can actually use inside of your landing page to make it just that much better. Now let's go ahead and add an image into our landing page so we can see how those assets are handled. So the first thing is we come into public and drop in a picture of some kind. I have launching.jpg. I found this image on unsplash.com, but of course the image can come from anywhere. But the idea here is to replace this Samsung Galaxy S21 image with something different. And so to do this, we're going to jump into our hero for this lead capture, and we're going to go ahead and import the image itself from Next.js, which this is the import right here. So back into that hero, we're going to bring this in. And now I'm going to go ahead and use image source and then use slash. And the slash is relative to public, which will be launching.png or actually JPEG. And then we also want to say that it's our landing page rocket or something like that. And then we'll go ahead and do our width being, let's do 600, and then our height being 600 as well, because I used a square image on purpose. So now I've got that image in there, which is great. So I just want to actually style it a little bit more. So I'll go ahead and add in rounded here. So we refresh that. Notice the spacing seems to be okay right now. Or actually I want rounded as a class on the image itself. So class name being rounded. And there we go. So we've got this rounding here. But I also want to separate my hero out a little bit more. So I'll go ahead and add rounded on there as well. And then I'll do MX8 and Y4, and we'll do PX4 here, which means that back into my layout, I'll go get rid of PX4 and just do BG gray 300 or something like that. And there we go. So now it's actually separated a little bit, but now we've got this little spacing issue inside of my landing page. So going back into that hero, we can add some padding in here. So PX like 4, save that, and there's that same sort of padding on both sides. Cool. So certainly not a perfect sales landing page, and it definitely could be improved, but the idea mostly being about the image itself And then of course that our actual landing page still works. Like it still can accept data in here. In this case, it totally does, which is great. So since that actually does work, I also want to do one more thing inside of my form and basically saying if it's okay, if the response is okay, then we'll go ahead and say if response okay. Then I'll go ahead and just clear out the form itself, which I'm going to go ahead and do with a reference. So we'll call this form ref. And we'll go ahead and say const, and this is form ref equals to use ref. And we'll set it to null to start out. We need to import use ref here, just like that. So with this form ref here, we can do form ref dot current dot clear, but reset. Okay, so let's go ahead and try that one again. And abc whatever at gmail.com, join list. And if all went well, great, it's there. And I could set a message and stuff like that as well. Otherwise, I'll go ahead and say alert error with your request, something like that. So you could use a lot of React things to just change the way it responds altogether. I don't think I need the response data at all. So I can go ahead and say that, let's go ahead and bring in a message and set message, and it's going to be equal to use state of just an empty string. And so if it's successful, we'll go ahead and say, thank you for joining. And if it's not successful, that's what we'll actually use. And so then in here, I'll go ahead and put another div. Really, I should probably just use a React component element, a fragment, if you will, which is what these empty components do. And basically we'll say message and the span of that message. Or rather, we'll just do a div here. And we refresh, abc at Gmail or whatever, join list. Thank you for joining. Great. A little bit more robust than what it was. Okay, so now at this time, we can start putting this into production once again. So I'll do git status. Actually, let's go ahead and use this. We'll go ahead and say updated UI with images and user messages. Commit. Yes. Let's go ahead and sync those changes. So once again, we will go back into our GitHub Actions and we will let this finish so we can see the production version of these in our staged value, right? So production in the sense that it will be deployed, not the actual production application itself, so that this will turn into this or vice versa, so that we have the correct things going. So let that finish and we'll come back. And so while this is working, let's go into S3 on AWS. So just do a quick search for S3 in here and then navigate into S3. And what we want to do is we want to take a look at the objects that are currently there. So if we go to staging, leads, landing, of course, this is staging. We've got our assets here, and there's our various assets. So Next.svg and Vercel.svg, both of those things are coming from that original public folder here, right? And I just added that file. So in short order, we should actually see our image coming through in here once the deployment finishes, which will take a little bit more time because of that image change. But it shouldn't take that much time as far as getting the actual image in here. So we'll see that here shortly. And like almost right after I said that, there's that image now. So this is actually where it's stored, right? So we don't have to do any of that. SST handles all of it for us. Now, of course, there is a way for us to handle it, but it is more complicated than this. It's not just adding an image to a folder and then it just goes where it needs to go. And then shortly it will be rendered as it needs to be rendered. As we'll see here too. My stage deployment is still going. So what I'm going to do here is I'm going to take this commit message and I'm going to have it as part of the pull request once that ends up happening. So to do this, I'm going to go into stage.yaml here and I'm just going to change the title and I'll just call it auto dash $, 2 curly brackets, and this is going to be github.event.head commit.message. mostly just to make the title based off of a commit message. So it makes it just maybe a little bit easier. Maybe not, but I like making it more than just a bunch of lists of basically stage changes, right? So at some point it will say stage changes 1,000 times. So now at least I can see, oh, there's the stage changes coming through. But what I will see is eventually it will just be that commit message. So with that in mind, we'll go ahead and say update auto PR title. We'll commit that. And then we probably don't need to automatically trigger the stage itself when the stage.yaml changes, because it does take a little bit of time. Probably should just be based off of the code in general. So I'll go ahead and remove that as well. And removed auto trigger for workflow. Commit that. Yes. Sync those changes. Okay. So with the actual PR already coming through here, if I refresh on my deployment, I should now see that option there. And what do you know? There is the image as well. If I go to inspect this image too, what I see is this image is coming relative to my CloudFront URL. In other words, it's actually a CloudFront optimized image as well, which is fantastic. And this is all thanks to SST. So at this point, what I want to do is I want to actually put these things into production. So once again, I will go to the stage changes. You know, I can review all of the different commits if I need to, or I could just approve the pull request by coming in here and come down, merge pull request, go ahead and merge it, and just let that thing go. And so once again, the actions should be triggered, and there it goes all the way through to our production application. Now those stage changes are still going into production. So basically here is my staged app. On purpose, we've got this live version of it staged, ready to go. And then here's my current production version that's not quite promoted to the latest example yet. And of course, if I go to join the list here, we should see, hey, thank you for joining. Great. We're on the right track as far as an application, a full built application, and then also on track with our production application. So the deployment does take a little bit of time. As I said, sometimes it takes a minute, sometimes it takes about 10 minutes. But I'll let this finish. In the meantime, I actually triggered off that staging deploy again because I want to have a new pull request with that message itself, which the message that's coming through, that will come through, is just simply staging deploy via SST to AWS. In theory, that's what that pull request will be. So we can just kind of polish that off. And then the main thing being, of course, that our production application is up and running as well. So I'll let all of those things finish and then we'll be back. After about 13 minutes, our production application was promoted and actually put into production, which we can see right here. We can also test this by adding in some emails in here and just verifying that we've got all of that working. Looks like it is. And then of course, if we go into our actual database itself, we should be able to see those new entries like that. Great. So that means our production application is fully ready and fully working. Now what I did off video was I created a little change to my stage application. That is, I added this exclamation mark because when I went off of that one-off trigger for that stage, it didn't end up working. In other words, this staging deploy right here, I went ahead and ran it and I got this error that ended up happening. Now the error is because Git cannot publish a pull request when there are no changes, which is exactly what happened. It created that error, which is nice. So that actually shows me that this is not going to make redundant pull requests in here as well based off of the stage. So back into my pull request, I now see what that one is. And there is the minor commit to trigger a pull request. And let's say, for instance, I ran that one more time. So now I have that minor change. I haven't approved that pull request yet. I'll go ahead and run that trigger one more time and just see what the result might end up being. But the main thing here is we now have a way to end-to-end deploy our production application with a stage in the middle, that it stops it right there so we can verify a number of things before we go into production, which I think is pretty great and pretty exciting. I'm gonna let this last piece finish so we can see if this ends up working the way we intend. And this is nearly complete, and something I realized that we did was we ran our migrations for staging, but we did not run them for our production. So let's go ahead and add that one in as well. just to ensure that that's done too. So we'll go ahead and do our production database migrations. And that, I think we just have the Pnpm run migrate. That should work just fine. So come in here and Pnpm run migrate. Great. Okay, so that's just a minor change there. We'll do git status, git add, git commit, updated production workflow, and then git push. This should not trigger anything because all we did was change the production workflow. So I will finish off that staging workflow to see if it will commit another pull request. And sure enough, it does not. It will not automatically create another pull request. However, what it did do was update the staging environment if it needed to be updated, which this is great. So all of these features are just a nice advantage to using all of this in action, right? GitHub Actions makes this really simple for us. And then since I updated that production workflow, I could actually come in here and approve everything. And this will now run that production workflow, which was minor changed to having our exclamation mark and those migrations. So inside of the job itself, we should see migrations as being one of the things that ends up doing, which we see production database migrations right there, which again, you could test that out and see if that ends up working for you. But that's pretty much it. We now have our production end-to-end example working. It's live and it's ready for you to start building and iterating on your application from here. Hey, thanks so much for watching. Hopefully you got a lot out of this one. Now, of course, we are at the beginning of what your app could be. I want you to actually transform this into a really functioning piece of software that you can then use. So this sales landing page is going to be more than just emails, but rather the entry point into something hopefully much, much better. So I also want to leave you with one challenge, and that is adding a custom domain to your application. Now, the way you're going to do this is by using AWS, and specifically Route 53, Cert Manager, as well as CloudFront. So once you get all those things in, you will have your own custom domain on top of this very powerful stack that we've seen throughout this project. So thanks again. Look forward to seeing you next time.